Hi everyone, how are you all? So in this session, we will continue the discussion of weekly quiz 24. In this weekly quiz, the topic was finite automata, and we were discussing this weekly quiz. The part 1 you can watch. This is weekly quiz 24 discussion part 2. Okay, so let's start. This weekly quiz you can find on the GATEOverflow website. You can go to the exam section and you can find on the GATEOverflow website, you can find this weekly quiz. Go classes 2024 weekly quiz 24 finite automata. You can check it out and you can attempt this weekly quiz. Okay, so let's start now. This question we have already seen in the last session. In the part 1, this question we have already seen, right? But I want to discuss this option C again. This option C I want to discuss again. Okay, so actually this option C also we have seen, right? Yes or no? In the previous part, in the part 1, this option C also we have seen, but I want to discuss this again with the easy method. Okay, in the part 1 we have seen method of option C, but that was complicated, that was very complicated. Now I will tell you very easy method for option C. Okay, so let's see this option C now. So so let's discuss this option C. For every language ll star equal to l star if and only if empty string belongs to L. So let's see what is this option C. So option C is saying that ll star is equal to L star if and only if empty string belongs to L. This is the option. Now let me tell you one thing. Just focus on this ll star. What is this ll star? Just focus on this. Remember what is L star? You know what is L star. L star means L power 0, union L power 1, union L power 2, union L power 3, union and so on. So tell me what will be LL star? What that will be? L means L power 1. Okay. Concatenation with. You concatenate this with L star. So what you will get, tell me? L star means L power 0, L power 1, union L power 2, union L power 3, union and so on. So tell me what LL star will be? So if you do this concatenation, what you will get? So ultimately you are going to get L power 1, union L power 2, union L power 3, union L power 4, and so on. Yes or no? So ultimately tell me what you will get. You will get L plus. Yes or no? You are going to get L plus. Okay. So this is very simple, that LL star, that is basically your L plus. Is this point clear? You can check. This is quite intuitive, that L star, this LL star, this is basically your L plus. Okay. So now the question, now what the option C is. Now tell me, if you understood this, that LL star is equal to L plus, if you understood this, now tell me what this option C is talking about. Now you tell me what this option C is talking about. You understood this, that LL star is equal to L plus. So now this option C basically you can change, and you can say that option C is saying that L plus is equal to L star if and only if empty string belongs to L. Now your option is this. Now this is your option. Now basically the question is asking when it will happen that L plus equal to L star. And this also we have seen, right? So you already know this, that tell me when it will happen. When does it happen that L plus that is same as L star? When it will happen? Do you remember? This we have already seen, if you remember. So tell me when it will happen that L star is equal to L plus. Tell me one thing. What is the only difference possible in L star comma L plus? Tell me L star comma L plus. What is the only difference possible between these two? Between these two, if you notice, the only difference possible is empty string. Yes or no? If you notice between these two, the only difference possible is empty string. That is the only difference possible. Correct? Agree with me? So the only difference possible is empty string. Means one of them, it is possible. See what I am saying. Let me tell you. So I am saying that you know that L star is equal to L power 0, union L power 1, union L power 2, union and so on. And you know what is L plus? L plus is L power 1, union L power 2, union and so on. So if you notice the only difference, this is the only difference. Okay, this is the only difference possible. And this means set containing empty string. So I am telling you that the only difference possible between L star and L plus that can be of empty string. This is the only difference possible is of, this is the only difference that is of empty string. Now you tell me, if language contains empty string, then this difference will never come. This we already know that if language contains empty string, if empty string belongs to language, then tell me what will happen. Then tell me what will happen. If language contains empty string, then what will happen? Then empty string belongs to L plus also. This we have seen already. Okay, so you can notice. And this will, so in this situation, you tell me, can I say L plus is equal to L star? Because L star will always contain empty string. L star always contains empty string. This you already know. L star always. See, L star always contains empty string. It always contains empty string. This you already know. This is the one thing. The second thing, when L plus contains empty string, tell me, when it will happen that L plus contains empty string? When it will happen? L plus contains empty string if and only if L contains empty string. So now you use these two result. These two result you use. L star always contains empty string and L plus contains empty string if and only if L contains empty string. This we already know. So now you tell me what will happen. If L contains empty string, then can I say that L plus will also contain empty string? So what will happen? So I can say that L plus and L star will be same in this situation. Okay. Next, second, you tell me, if L does not contain empty string, if empty string does not belong to L, then can I say that empty string does not belong to L plus? Yes or no? In this situation, I can say L plus is not same as L star. Okay, because L star will always contain empty string. L star will always contain empty string, but in this situation, L plus does not contain empty string. So in this situation, L star, L plus, they are different. So tell me, what is the final result? Can anyone tell me what is the final result? So when it will happen that L plus is same as L star, when it will happen, tell me. This will happen if and only if empty string belongs to L. Yes or no? So when this will happen? Very simple. So I can say this is your result. You got your result. So this is the result that L star is same as L plus if and only if empty string belongs to L. Please tell me, did you understand this? Let me know. So very simple. This proof is very simple, right? So now if you notice your option C, now let's come back to option C. So now you can check this option C. For every language L, LL star is equal to L star if and only if empty string belongs to L. So this result you can simply say that for every L, okay, this option is saying that for every L, L plus is same as L star, L plus is same as L star if and only if empty string belongs to L. And this statement you already know this is true. Okay, we have seen that this is true. So now this explanation of option C, please tell me, did you understand? This is very easy explanation. I hope this explanation is very easy, right? Okay, so very easy proof. This is very easy proof of option C. You can easily prove it. Okay, so I hope you understood this. Now let's move on. Let's see this question. This is a very interesting question. A deterministic finite automata is given to you. DFA is given to you. And the question is asking, how many strings of length 8 have 1 in second, third, sixth, seventh position? So this is a very interesting question. Let me tell you, this question is taken from ISRO. This question is taken from ISRO. So this question came in ISRO 2014. You can check it out. This question is taken from ISRO. So this question we have put in our weekly quiz, question number 9. So this is a very interesting question. Now let's solve it. Okay. So let's start this. Similar question has come in the GATE exam also. Similar, not exactly same. See, this is your ISRO question. This ISRO question we have put in our weekly quiz. In our weekly quiz, the same question I have put. So this ISRO question we will discuss. We will discuss this question. The similar question has come in the GATE exam also. So you can notice, yes, this question is different from the ISRO question. There is a small difference. The DFA is different. Okay. But the point is, similar question has come in the GATE exam also. You can check it out. So this GATE question I give you as a homework. You can try this, but I will discuss the ISRO question. Is this point clear? So this GATE question I will give you as a homework. You can try this question yourself. Okay. But let's discuss this ISRO question. So this ISRO question is quite interesting. So let's see what the question is asking. The question is saying that this DFA is given to you. This DFA is given. Let S denote the set of this S. What is this S? This is a set of, in this you have 8-bit strings. Okay. Basically, 8-bit strings means 8 length strings you have. Okay. So in this you have strings of 8 length whose second, third, sixth, seventh bits are 1. So in this S, what you have? In this you have those strings. First you tell me, in this set S, how many strings are there? Can anyone tell me, in this set S, how many strings are there? So remember, the question is saying that in this S you have W, where length of W is equal to 8. And what this question is saying that, so basically this string you have 1, 2, 3, 4, 5, 6. So this string you have. So let's assume this is your W. Now the question is saying that second, third, sixth, seventh. Okay. So the question is saying second, third, then 1, 2, 3, 4, 5, 6, 6, 7. So these bits are 1. Okay. The question is saying these bits are 1. So tell me, how many strings you have in this set S? In this set S, how many strings you have? Your sigma is 0, 1. This is your sigma. Already it is saying bit strings. Okay. So you can check. So tell me, in this set S, so in this set S total, you have, there are two positions here, right? Yes or no? So you can notice there are 2 positions. There are 2 choices here. Here you can put 0 or 1. Here also you have 2 choices. Here also you have 2 choices. And here also you have 2 choices. So finally, I can say in this set S, you have 2 power 4. That is 16 strings. Remember, in this set S, you have 16 strings. What the question is saying? The question is saying, how many of strings in S are accepted by M? The question is saying that in this set S, how many strings are there which are accepted by M from this S? So this is the question. The question is, from S, how many strings accepted by M? Did you understand the question? Please tell me, how many strings accepted by M? Accepted by the machine M. This is your question. Okay, now let's solve it. So you already know that second, third, sixth, and seventh, these positions are 1. The remaining positions we have choice. In the remaining positions, we have two choices. Either you can put 0 or you can put 1. Either you can put 0 or you can put 1. In the remaining positions, you have choices. Okay, so this is a simple question. Now let's solve it. See, this type of question you can solve using the DFA very easily. So let's try to solve this question from the DFA. You already know that second position should be 1. Basically, this type of string you are looking for. We are looking for this type of string where this is 1, this is 1, this is 1, this is 1. Okay, so our focus should be on this type of string. Is this clear? Our focus should be on this type of string. So you tell me, initially, when you are in the initial state, and remember, we want to accept. We want to find out how many strings of this type are accepted. Okay, this is our target. Remember, our target is this type of, how many strings are accepted. This type of strings. Okay, this type of strings, how many are accepted. Okay, so this is our target. How many of this type of strings are accepted? So very simple. This is our target. So now you tell me. Ultimately, at the end, we want to go to final state. So initially, in the first position, I have choice. Agree with me? Okay, yes or no? Here I have choice. Here either I can put 0 or I can put 1. Correct? Okay, so let's start. Maybe the first position is 0 or the first position is 1. If the first position is 1, then this type of string you are looking for. If the first position is 0, then this type of string you are looking for. Is this point clear? Okay, so let's check. So tell me 0, 1, 1. If you check 0, 1, 1, then what will happen? Means if you take 0, first you take 0, now you take, okay, so this is what I'm saying. Let's check this type of string 0, 1, 1, then dot dot, then 0. Okay, so this type of strings, let's see. Okay, let's see this type of string. So our target is, so tell me now, if you put 0, if you see 0, then you will go here. If you see 1, then you will go here. If you see another 1, then you will go here. So can I say you are here? You are in this state? Yes or no? Okay, so let me call the states. For example, A, B, C, D, E. Okay, so you are in the state B. When you see this symbol at this point you are in the state B. Okay, so now you tell me, remember you are in the state B when you see this. So 0, 1, 1. At this point, you are in state B. Now you tell me, now what will happen? In this state B, tell me, now remember one thing, you can read two symbols. You can read two symbols, then you need to read 1, 1. And then one last symbol. One last symbol you need to read. So first of all, you tell me, you need continuously 1, 1 you need. Okay, two symbols. Now you are in the state B. Now you are standing here. Now you tell me, which symbol you should read? If you read 0, then you read 0. See what I'm saying? I am saying that from this state B, you need to read two symbols. This is what you need. You need to read two symbols you need to read. And after that, 1, 1 definitely must come. Okay, and here you must be in the final state. Here you must be in the final state. Is this point clear? So this is the point. So tell me, two symbols you need to read. If you go in this direction, from this state B, if you read 0, means if this symbol you make 0, if this symbol I put 0, here you already are in B. If I read this symbol 0, now what will happen? Then I will go to state A. Yes or no? I will go to state A. So you can write like this, state A. Now in this state A, if I read 1, can I ever go to final state? In this state A, if I read this one, I can never go to final state, because remember one thing, after this symbol, only three choices, only three places are there, and this would be 1, 1. Okay, basically now you have four choices to go to final state. Okay, remember, now you have only 4 choices to go to final state, but you are in this state now. Now you are in this state A. Okay, so once you read this 0, then you are in the state A. Now you tell me, in the state A, now can you go to final state? What is the minimum string you need to go to final state from A? You are in A. If you want to go to final state, tell me what is the minimum string you need to read? What is the minimum string you need to read? Minimum string you need to read. That is 0, 1, 0, 1. So I can say that this strategy will not work. Agree with me? Because now I am saying that, see, from this B, from this state A, if you want to go to final state, if you want to go to this final state, then remember, if you want to go here, then minimum string that you need, then minimum string, okay, the minimum string that you need is 0, 1, 0, 1. But I want this type of string. So this type of 4-length string, can it take me to final state? Tell me. This type of 4-length string, can it take me to final state? No. So I can say that definitely this cannot be 0. Okay, is this clear to everyone? So this cannot be 0. So I cannot go. Remember, from this state B, I cannot take this 0. So I need to take this one. From this state B, I need to take this one. This is must. Okay, now where I am? Tell me. Now I am in the state C. Okay, now you are in the state C. Now tell me, in this state C, can you notice? I definitely need at least 0, 1 I need in this state C. In this state C, can I go to state B? Can I go to state B from this state C? Now only only 4 symbols are remaining. This type of strings I am looking for. I am looking for this type of string. So you tell me, from this state C, can I go to state B in the direction of state B? One symbol will be consumed. from this state C, if I go to the direction of state B, then one symbol will be consumed. Then I need 3 symbols minimum to go to final state. So if I go to state B, then I need 1, 1, 0, 1. Yes or no? From this state C, if I want to go to final state from the B side, I hope you are getting this point. See what I'm saying. 0, 1, 1, 1. At this point, you are in the state C. Now, what I'm saying that if you go to the side of state B, means if you take this 0, if you take this 1, if you take this one, now you are in the state B. From B to final state, you have 1, 0, 1. You need 1, 0, 1. Okay, you need what? You need 1, 0, 1. So definitely I cannot do that. Yes or no? That is not possible. Contradiction. Again, there is a contradiction. So again, you cannot go. Okay. So from state C, where I can go? I can go to where? From this state C, I can take 0 and I can take to state D. Okay. I can take 0. Now I am in the state D. In the state D, I need 1, 1. I need 1, 1. In the state D, I need 1, 1. So now I'm in the state E. Okay. In the state E, anything can come. Yes or no? In the state E, anything can come. So in the state E, this symbol can be 0 or 1. This symbol can be 0 or 1. So I can say 2 strings are accepted. Can you notice that this type of 2 strings are accepted? See, this type of, how many this type of strings are accepted? 2 strings. 0, 1, 1, 0, 1, 1, 1, then 0, 1, 1. The only change is in the final symbol. Is this point clear? So these 2 strings are accepted. Please tell me, did you understand? Is this point clear? See, this is a very, I can say, yes, there is no systematic method here, but very like, I can say the way we have done. Similarly, you can also check it out. The way we have done, okay, we are checking the possibilities. We are checking all the possibilities. Remember one thing, you cannot miss any possibility. Yes or no? You cannot miss any possibility. If you miss any possibility, then you will lose marks because the options are 0, 1, 2, 3. This question can be analytic question also. They can give you numerical answer type question also. Let's assume options are not there. Okay, it is also possible that there are no options. So you cannot miss any possibility. You need to check all the possibilities. So I'm going step by step. Okay, very slowly, step by step, I'm going and I'm checking. Okay, so this direction is over. Now let's see this direction. How many this type of strings can be accepted? 1, 1, 1, and so on. How many this type of strings I can accept? Okay, so let's check. So let's check how many this type. 1, 1, 1, 1, 1, 1, then 1, 1, then this. Okay, so this type of strings, how many this type of strings are accepted? So first you tell me, you are doing this one. Okay, yes or no? Initially, from the, this is your state A, this is state B, this is state C, this is state D, E. So tell me, at this point, there is no choice. See, here in these 3 positions, there is no choice. So tell me where you will go. You will go to 1, 1, 1. That means you are in the state A. Okay, you are only in the state A. Now see something interesting. This is very easy. Tell me one thing. From state A, you are in the state A. If you want to go to final state, in 5 jumps, you want to go to final state in 5 jumps. So how many 5 length strings are there? Tell me how many 5 length strings are there? If you want to go to state E, then how many 5 length strings? One thing is necessary, that you need 0, 1, 0, 1. Do you agree with me? See, minimum, if you notice one thing, from state A to state E, minimum 4 length string you need. I can say minimum 4 length you definitely need. Okay, it means from state A to state E, this 0, 1, 0. If you take this 0, then this one. So the point is something like this. See what I'm saying, 4 length strings you definitely need. Now let's check. So either what you can do, from this state A, Either what you can do, this is what I'm saying, from state A to state E, let's see 5 length strings. Just tell me how many 5 length strings are there, which can take me to this final state. Tell me all the 5 length strings. All the 5 length strings. See, either you can do 1, then 0, 1, 0, 1. Either you can do 1, then 0, 1, 0, 1. Either you can do this. Or what you can do? Are you getting my point? Either you can do this, means 1 and then 0, 1, 0, 1. Or what you can do? Or you can do this 0, 1, 0, 1. But in the middle, you can read this 0. So what you can do? You can do 0, 1, 0. And then you can read this symbol 0 and then you can read 1. Okay. Is there any other choice? Yes. 0, 1, 0, 1. Then here you can read 0 or 1. 0, 1, 0, 1. 0, 1, 0, 1. And at the end, you can read 0 or 1. Can you notice none of these strings, they have consecutive 1, 1. Can you notice this? None of these strings, they match this. They are matching this. Yes or no? None of them is matching this. Okay, only these are possible. Only these are possible. And none of them are matching this. Is this point clear? Can you notice? None of them is matching this. If you do this 0, 1, 1, okay, so this will be I can say 0, 1, then 1, 1. It will be a long way. It will not be a 5 length string. See, if you do this, tell me if you do this, then it will not be a 5 length string, right? See, 0, 1, then 1, then 1, then 0, 1. It will not be a 5 length string. It is not going to be a 5 length string. So only these are the 5 length string possible, which can take you to from A to E. From A to E. These are the 5 length strings. Only these are the 5 length strings which can take you from A to E. These are the 5 length strings. And none of them is of this type. None of them has this type of structure. So I can say that this type of how many? None. This type of none accepted. None of them is accepted. So finally your answer is what? Answer is 2. Yes or no? So your final answer, that will be 2. This will be your final answer. This is a very interesting question, let me tell you. Sometimes in the GATE exam, this type of question will definitely come. And already this type of question has come in the GATE exam. See, this is a GATE exam question you can try. Similar type of question is there. Okay, so this GATE exam question you can try. I give it to you as a homework. You try this question today, but this ISRO question we have done. Okay, is this point clear? This question, did you understand this question? Sometimes this type of questions will come in the GATE exam. Definitely, at least one question of this type where you have to do systematic analysis. Did you notice one thing, that this method is hit and trial? Yes or no? The method that we have tried is hit and trial. Yes or no? But this was systematic. See, this is the difference. What we have done is systematic. Okay, systematically, step by step you do, so that you don't leave any possibility. So this is also, of course, this is hit and trial. The method that we have tried, that is hit and trial. But the point is that systematically you have to do. I hope this point is clear. Okay, so finally your answer will be 2. This your answer will be. Let's move on now. Now some of you might be thinking, sir, we can find the language and then we can find how many strings are there of length 8. Yes or no? Agree with me? Some of you, is there anyone who is thinking that first we find the language, then we find how many 8 length bit strings are there? Maybe we can get some clue. For example, first you find this language. First you find what is the language accepted. Then maybe you can get some clue. Anyone? Is there anyone who is thinking like that? Please tell me. Is there anyone who is thinking that from this DFA we find the language, maybe we can get some clue. Okay, maybe we can get some idea what type of strings this DFA is accepting. And then we can try to find out how many 8 length strings are there. But the point is, for this DFA, language is also very complicated. I know you are thinking, but for this DFA, the language is also very challenging. I have given to you. You can read my answer on this ISRO question. Okay. On the GATEOverflow website, what you do? On GATEOverflow website, you check my comment. On GATEOverflow website, under this ISRO question, you can check it out. This is the language. The language itself is very complicated. This is the language. Okay. So you check it out. I have given to you the language I have given to you. But the point is, using this language, first of all, finding this language will take a lot of time. Okay. You are in the exam. Let's assume you are in the exam. First, you find the language. It will take a lot of time. And then you will solve the question. So it will take, ultimately, it will take a lot of time. So the most efficient way for this question, to solve this question, is hit and trial. Is hit and trial. Is this point clear? Please tell me, is this point clear? So for this type of question, the best way is hit and trial. Okay. So remember one thing, if the DFA is complicated, see, if the DFA is standard, you can find the language. If the DFA, this is my, I can say, this is my suggestion to you, this is my advice to you, that if DFA is simple, if you have simple FA, if you have a finite automata, which is very simple finite automata, or I can say standard finite automata, which you have already seen, or if this is standard finite automata, in these two cases, you can find the language. In these two cases, you find the language and solve. But remember, if the finite automata is complicated, if finite automata is complicated, is complex, okay, then solve directly. Then don't find the language. Okay, then solve directly. I hope this point is clear. Okay, some finite automata are standard, right? Yes or no? Some finite automata, they are standard. You can easily find their language and then you can solve the question. But if the finite automata is complex, then you solve directly. Don't find the language. Okay, let's move on. Let's solve this question. Question number 10, weekly quiz 24. Assume empty string is denoted by this symbol. Suppose L is a language, means the sigma is a comma b. So you can notice L is subset of sigma star. That means L is a language. Now this language is defined as follows. The question has defined the language. Okay. So the definition of the language is given to you. Now the question is asking some options. Some options are given to you. Let me tell you, this question is taken from John C. Martin book. So this is a very nice question. Okay. So this is taken from John C. Martin, TOC, Theory of Computation book by John C. Martin. So this is a very nice, very nice, nice question. You can check it out. Okay. I have taken this question as it is. I have taken this question from John Martin and we have put in the weekly quiz. Okay. So let's solve it now. Let's solve. So the question is saying that this language, definition of the language is given to you. This is the definition of the language. Remember, this is the definition of language. Defines the language. This defines strings in language. Strings in language L. Okay. So what is the definition? And the question is asking, for any string in L, which of the following statements are definitely true? Which statements are definitely true? This is the question. Okay. So let's solve it. So what is the definition of L? The question is saying that L is defined. Okay. The definition of L is given to you. So what that is? That is like this. Empty string belongs to L. Okay. This is already given to you, that empty string belongs to L. The second point is saying that for every X belonging to L, XA, XBA are also in L. Means the question is saying if X belongs to L, then XA, okay, this also belongs to L, and XBA, this also belongs to L. Okay, so this is the definition. First you understand this language, then we will solve the question. This question we will solve, but first you understand the language. Can you give me some strings in the language? Create some strings in the language so that you can understand the language. Create some strings. Okay, so tell me, in this L, what type of strings you have? Notice one thing, that you can start with empty string. Means empty string is in the language. If empty string is in the language, then Basically, whatever string you have, you can put A at the end. Either you can put A at the end, or what you can do, or you can put BA at the end. Notice, whatever string you have, either you can put A at the end, or you can put BA at the end. Please notice, either you can do this, or you can do this. So I can say empty string belongs to L. So definitely empty string, you can put A at the end. Okay, means this empty string, this is your X equal to empty string. So that simply means that A you can put at the end. This lambda A, this also belongs to L, and this lambda BA, this also belongs to L. Okay, so these belong to L. So finally I can say A belongs and BA belongs. Next, you tell me what you will get. Okay, this is done, right? From this, whatever you can create, that has been created. This is done. Now you tell me from A what you can create. From A what you can create. Either you can put A at the end, or you can put BA at the end. From this, what you can create. Either you can put A at the end, either you can put A, or you can put BA at the end. From this, what you can create. You can either put A at the end, or you can put a BA at the end. Did you notice? Okay, this is a very simple language, right? Yes or no? So this is your language. Now the options. Now tell me what the question is saying. The question is saying that the first option, the number of A's in W is more than number of B's in W. Is this true? Is this true for every string? The number of A's is more than number of B's. Is this true? This statement is not true. What are the counterexamples? What are the counterexamples? Tell me. See, option 1 is not true. Option 1, that is not true. You can notice. Option A is saying, what option A is saying? In every W, the number of A is more than number of B. Option A is saying in every W, number of A in W is more than number of B in W. So this statement, this option A is false. And what are the counterexamples? So tell me the counterexample. The counterexample you can notice. BA is the counterexample. This BA is the counterexample, and empty string is the counterexample. This BA is also counterexample. Okay, so these are the counterexamples. Counterexamples are, this is counterexample, this is counterexample, BA is counterexample, and so on. Okay, you can also take BA, that is also counterexample. So these are the counterexamples. Is this point clear? Okay, remember, these will be the counterexample. If you notice, the counterexamples are like this. All the BA power n. These are the counterexamples. Yes or no? These strings are the counterexamples. Can you notice? Can you notice these strings are the counterexample? These strings are the counterexample. BA star. These strings are the counterexample because these strings belong to L. Okay. In this empty string, how many A's are there? Please tell me, in this empty string, how many A's are there? How many A's are there in the empty string? 0. How many B's are there in the empty string? How many B's are there? 0. Can I say number of A's is equal to number of B's? So this option is, this option A is false. Yes or no? For this string, option A is false. So this string I can use as a counterexample for option A. Is this clear? Why empty string belongs to the language that is given? Why empty string belongs to the language that is given? It is already given. It is already given that empty string belongs to the language. See, this is the definition of language. Please check it. This is the definition of language. In the question, this is given. This is given in the question. This is given in question. The question is saying, read this line. Please read this line. Read this line in the question. What this is saying? This is saying that empty string belongs to L. Okay. Second point, for every X in L, means if X belongs to L, then what will happen? Then XA belongs to L, XBA belongs to L. So this is given in the question. This is the definition of language. This is the definition of L. Is this clear? Please tell me. So the question is saying that empty string belongs to L. Empty string belongs to L. If X belongs to L, then XA also belongs to L. XBA also belongs to L. Is this point clear? So remember, in this L, what you have? In this L, you already have empty string. You already have empty string. The question is saying, this is given in the question. This is given in the question. And then the question is saying that if X belongs to L, then XA will also belong to L. See, empty string belongs to L. See, empty string belongs to L. So empty string A, which is same as A, that also belongs to L. Empty string BA, that is same as BA, that also belongs to L. So because of this empty string, who will come? Because of this empty string, A will also come, BA will also come. Because of this empty string. Because of this A, who will come? Because of this A, who will come? See, A belongs to L. So now this A is your X. Here, this lambda was X. Now this A is your X. So because of this A, who will come? A will come and ABA will come. So because of this A will come and ABA will come. Is this point clear? Tell me, if I make this X, if X belongs to L, if X is equal to BA, then what will come? If X is equal to BA, then BA will come, BA will come, and so on. Like this, you can keep creating. This is a finite language or infinite? This language is finite or infinite? This is infinite. You can keep creating the strings. Is this point clear? Please tell me, everyone understood the language or not? Did you understand the language? The definition of language is given in the question. See, this is a very nice question. The language has been defined. The language has been defined. See, language has been defined. The language definition is given to you. This language definition is given. Please tell me, did you understand this type of question? This type of question, are you comfortable now? First you understand the language, then you solve the question. Okay, now let's come to our option A. So tell me, option A is false or not? Option A is saying that in every string, number of A is more than number of B. This is option A. Option A is saying the number of A is more than number of B. That is false. That is false. And who is the counterexample for option A? For option A, the counterexample are these strings. These strings are the counterexample. I hope this point is clear. So these strings are the counterexample. This is also the counterexample. So very simple. Now tell me, what about option B? What option B is saying? The number of A's is greater than or equal to the number of B's. The number of A's is greater than or equal to the number of B's. You tell me, you look at all the strings. Are they satisfying this condition? The number of A's is greater than or equal to the number of B's. All the strings, are they satisfying the condition? Yes, they satisfy. This option is true, but how will you prove it? But how can you prove it? This option B is true, but how can you prove it? Please tell me, how will you prove it? Option B. Let's focus on option B. See, option B is satisfied by string, this string, agree? Option B is satisfied by this string. Can I say? Can I say option B is satisfied? Can I say option B is satisfied? Okay. So option B is satisfied. By this string, option B is satisfied. Yes or no? This string will satisfy option B. What is option B? Option B is saying that number of A is greater than or equal to number of B's. Yes or no? So option A is satisfied by this string. Then what you are doing, notice. See, please tell me, if W, you have a string, let's assume this question I am asking. Assume W has more A's, means number of A's is greater than or equal to number of B's. Assume in W you have this. Okay. There is a string W in which you have this. Now you tell me, in this W, if I add A or if I add BA, will this condition satisfy or not? Please notice, assume that W satisfies this. W will satisfy this condition. Let's assume there is a string W which satisfies this condition. Let's call it condition C. Let's call it condition C. So now you tell me, if I do WA, then will this condition hold? Will this condition hold? Yes, this also, here also the condition C will hold, yes or no? Agree? Because I am adding one extra A. So condition C holds. What about this one? What about this one? Can I say condition C holds? If I do this, here also condition C will hold, yes or no? Agree with me? So whatever you do, can you notice condition C will hold? So this is what I am saying. I am saying that empty string will satisfy this condition. Empty string will satisfy this condition. Then either you are adding A or you are adding BA. So definitely this condition will always satisfy, yes or no? Agree with me? So let's call it condition C. Let's call it condition C. Now you can easily notice that if W satisfies condition C, if W satisfies, if W, or I can say if X satisfies, if X satisfies condition C, then who will satisfy? Tell me. If X satisfies condition C, then so does XA comma XBA. Yes or no? Agree? If X satisfies condition C, then XA, XBA, they will also satisfy condition C. So condition C will always hold. Please tell me this proof. Is this proof clear to everyone? See, if W satisfies this condition, then WA will also satisfy this condition and WBA will also satisfy this condition. And you can notice the starting point also satisfies this condition. We have already seen that empty string satisfies this condition. So please notice this option B. You can prove this option B. This option B is true. This option B is saying that number of A is greater than equal to number of B. Let's call it condition C. Let's call it condition C. Now, this is actually true. This option B is actually true. Why? What is the proof? What is the proof? The proof is like this. See the base case. What is the base case? The base case is empty string satisfies C. Yes or no? Empty string satisfies condition C. This is the base case. This is the base case. Agree? Empty string satisfies condition C. That is the base case. And then what you have? Then finally I can say that if X satisfies condition C, if X satisfies condition C, then you can easily see XA will also satisfy and XBA will also satisfy. They will also satisfy condition C. Yes or no? They will also satisfy condition C. If X satisfies condition C, then XA, XBA, they will also satisfy this. Okay. I hope this point is clear. So option B is actually true. What about option C? Every string ends with A. Every string ends with A. Is this true? Every string ends with A. Is this true? This is not true. Who is the counterexample? Please tell me who is the counterexample. Look at option C. Look at option C. Option C is saying that every string ends with A. The counterexample is this. So this option C is actually false. And the only counterexample, remember, the only counterexample is empty string. This is the only counterexample. Do you agree with me? So remember one thing. If I say that every non-empty string ends with A, will it be true? Will it be true? Every non-empty string ends with A. Every non-empty string in L ends with A. Ends with A. Yes, this statement will be true. This will be true. Why this will be true? Because look at the language. See, look at the language. Whatever string you are creating, that is ending with A. Yes or no? Just look at the language. Your language, just look at the language. You have lambda, but lambda does not end with A. This lambda does not end with A, but after that, every string will end with A. Yes or no? Because whatever you do, in the end, you are either putting this or you are putting BA. So can you notice every string will end with A? Other than this empty string, can you notice every string, every other string is ending with a. Every other string that is ending with a. Because ultimately what you are doing, this is what you are doing, that whatever string you have, either you are putting a at the end or you are putting ba at the end. But the point is you are always ending with a. Very simple, right? So this option C, this is false. Who is the counterexample? The only counterexample is empty string. The only counterexample is empty string. But remember, this statement is true. Every non-empty string ends with a. This is actually true. This statement is actually true. What about option D? W does not contain substring BB. W does not contain substring BB. Is this true? Yes, this is true. How will you prove it? W does not contain substring BB. This is your option D. W in L does not contain BB. Okay, does not contain BB. Tell me, how will you prove it? Again, you can prove it very easily. What is the base case? What is the base case? Tell me. Is the base case satisfied? Is the base case satisfied? Does not contain BB. Does not contain BB. So you can notice empty string does not contain BB. Empty string does not contain BB. You can notice in the empty string, there is no BB substring. Does not contain BB substring. Okay. So now you tell me. So this is the base case. Now you tell me, if W does not contain BB, you tell me a simple point I'm asking. A simple point I'm asking. If W does not contain BB, if W does not contain BB, then you tell me a few questions. If W does not contain BB, if W does not contain BB, is it possible WB can contain BB? Is it possible? Please tell me. Is it possible WB can contain WBB? WB can contain BB? Is it possible? Please tell me. Please tell me, is it possible? If W does not contain BB, is it possible that WB contain BB? Yes, it is possible, right? Yes, possible. Yes, it is possible. Because W does not contain BB. W does not contain BB. Maybe W is like this. Maybe W is like this. Maybe this is W. Now you can notice that what is WB? What is WB? Now you can notice WB is this. Yes or no? So if W does not contain BB, is it possible WB can contain BB? Please tell me. Did you understand this? If W does not contain BB, is it possible WB can contain BB? Yes, it is possible. It is possible. Maybe W is like this. In this situation, you can notice WB that contains BB. But notice one thing. If W does not contain BB, then is it possible? Is it possible that WA contains BB? WA contains BB. Please tell me. If W does not contain BB, W has no BB. Okay, in this W, this is your W, this is your W. In this W, you don't have BB. Now if I add this, can I create BB? Can I create BB? Can I create BB? No. Is it possible? Is it possible? The answer is not possible. Yes or no? Very simple. Similarly, you tell me, if W does not contain BB, is it possible WBA contain BB? See, W does not contain BB. This does not contain BB. Now, if I put BA, yes, here actually it is possible. Yes or no? If W does not contain BB, is it possible that WBA contains BB? It is possible, but actually, one thing here actually it is possible. But if you already know that all the strings are ending with A, okay, so you already know that in the language all the strings are ending with A. See, if W does not contain BB and W ends with A, W ends with A. Now you tell me. Now you tell me. If W does not contain BB and W ends with A, W ends with A. Now you can notice that this statement is also true. Is it possible that it contains BB? Not possible. Not possible. Okay. So now let's come back to our option. See our option. Now we are saying that you already know that all the non-empty strings they end with A. Yes or no? You already know this. We already know what we know. We know that this we have already proven. We know that every non-empty string ends with A. Every non-empty string in L ends with A. Correct? Ends with A. This we already know. Yes or no? Now you tell me. So W is in L and you already know that W ends with A. Okay? All the non-empty string. So you can notice, first of all, lambda does not contain BB. So can I say that this A, from this lambda, what you can create? Tell me. From this lambda, what you can create? You can create only these strings. They also do not contain BB. See, they also do not contain BB. Yes or no? Do not contain BB. You can notice. Lambda also does not contain BB. So from this lambda, you can create A, BA. These strings you can create from lambda. And these strings, they do not contain BB. And you can notice they are ending with A. They are ending with A. Now, whatever you do, so tell me, from this you can create AA or ABA. From this you can create BAA or BABA. So can you notice you can never create substring BB? Yes or no? Because you are always ending with A. You are always ending with A. So if I add A, you cannot create BB. If I end with BA, then also you cannot create BB. Is this point clear? Please tell me. Because you are always ending with A. You are always ending with A. So whatever you do, if you keep doing like this, then you can never create BB. Because you are always ending with A. So that is the reason you can never create BB. So this is your answer. Please tell me, did you understand? Did you understand this question and all the options? Please tell me. This question and all the options, did you understand? Let me know. Let me know. Can you create the recurrence relation for number of strings of length n in this language? So this is a variation I am asking. A variation I am asking. So you know this language. You already know this language. So this language, what this language has? This language starts with empty string. Then from this empty string, it creates two strings, A, BA. Yes or no? Then it creates two more strings from each, A, BA, BAA, BABA. From every, okay, yeah, yes or no? Like this, agree? So this is the point. Now you tell me, what will be the recurrence relation for, let's assume that Fn. Fn means number of strings of length n in L. So that is the number of strings of length n in L. Tell me, what will be Fn? Can anyone tell me what will be Fn? What is the recurrence relation? In this language, the number of strings of length n, that is your L, that is your Fn. In this language, how many strings of length n you have? Of length n you have. So what your recurrence relation will be? So let's find Fn. Remember what is Fn? Fn is number of n length bit strings. Number of n length strings in L. So you tell me, how will you create a n length string? If I want to create n length string, then how will I create? If I want to create n length string, then how can I create? See, either I can create from n minus 1 length string. Agree with me? This n length string I want to create. I want to create n length string. Then what I can do? Either I can create from n minus 1 length string. So if this is n minus 1 length string, if this is n minus 1 length string, Then what I will add at the end? I already have n minus 1 length string. Then what I will add? I can add a. Yes or no? I can add a. So very simple. Now you tell me, if I create from length n minus 2, means this is your length n minus 2, then what I can add? I can add ba. Yes or no? So this is the point. So I am saying that if you want fn, this fn is equal to, either you can create from n minus 1 string. This fn, what you can do? This is your n. This is your n length. What you can do? Either you can add a in the n length string. So you count all the n length strings, count the number of n length strings, sorry, n minus 1 length strings. What you do? You count all the n minus 1 length strings, you count all of them, and then you add a plus. Okay, so you count all the n minus 1 length strings, you count these strings, and then you add a. Or what you can do? You can count all the n minus 2 length strings. You can create all the n minus 2 length strings, you can create, and then you can just add ba. Just add ba. So this your answer will be. So you count all the n minus 1 length strings, you count all of them, then at the end you add a. Similarly, you count all the n minus 2 length strings, you count all of them you count, then at the end you can add ba. So finally your answer is fn is equal to fn minus 1 plus fn minus 2. This is your recurrence relation. And what are the base conditions? So fn is equal to fn minus 1 plus fn minus 2. And what are the base conditions? Tell me, what are the base conditions? The base conditions are f1, that is only 1, f0, that is only 1, f2, that is 2, f2 is 2, f2 is 2, either a or ba. f0 is 1, that is lambda, f1 is 1, that is a. Okay, so these are the base conditions, and this is your recurrence relation. Please tell me, did you understand the complete analysis of this question? Did you understand? So this is John C. Martin question. Did you find this question nice? Is there anyone who found this type of question? They can ask this type of question in the exam. They can define some language and you need to analyze this language. Yes or no? We need to analyze this. Analysis. The question is based on analysis, nothing else. Tell me one thing. For this question, do you need to know some concept? To solve this question, do you need to know some concept of theory of computation? Do you need to know some concept of discrete mathematics? Some concept of operating system? Some concept of C language? No. This type of questions are analysis based questions. Something is already given to you. Some definition is already given to you. This is the definition that is given. Okay. See, this definition is given to you. And the question is asking, can you analyze? The question is asking, can you analyze the given definition? The given data, can you analyze? So this type of questions are very nice. Always something will be given to you, and using that you need to analyze some options. Okay, so anyway, now let's move on. Let's see this question. This is your weekly quiz, question number 11. This question is taken from GATE exam. The same question. This question is taken from GATE 2012. Okay. So this question is your GATE exam question. So let's solve it. So the question is asking, what is the complement of the language accepted by NFA? This NFA is given to you. What the question is asking, can anyone tell me? Can anyone tell me what the question is asking? What is the complement of language accepted by this NFA? Complement of language. The question is asking complement of language. Remember, the question is asking what is the complement of the language. For example, let's call this NFA N. This NFA N will accept some language. There is some language. What the question is asking? The question is asking this language, its complement. The complement of this language, the question is asking. This is your final question. Okay. So tell me, what is the language of this NFA N? What is the language for this NFA? This NFA is already given to you. What is the language? L of n. So what are the strings in this language? Your alphabet is only A. This is your alphabet. So you can notice A is accepted. Please tell me, from the initial state, is empty string accepted? Is the empty string accepted? Can you accept empty string from here? From here, without reading any symbol, can you go to final state? From this initial state, this is your initial state, without reading any symbol, without reading any alphabet symbol, can you go to final state? No. So that is the reason I can say empty string is not accepted. A is accepted. Okay, this A is accepted. What about double A? What about double A? Is double A accepted? So let's call, for example, let's call this state P, this state Q, this state R. So tell me, double A is accepted or not? Double A. Yes, double A is accepted. See what you can do. From the initial state, you can read A. This double A is accepted. What you can do, tell me. To accept double A, what you will do? From the state P, you will read A, you will go to state Q. You will go to state Q. Tell me what you will do in the state Q. What you will do in the state Q? Without reading any symbol, you will go to R. From this Q, without reading any symbol, you will go to R. Without reading any symbol, you will go to R. From this state Q, for free, you can go to R. From Q to R, you can go for free. Without reading any symbol, you can go to R. From R, you can go to P for free. And then you can read this symbol A and you can go to Q, which is your final state. So you can notice double A is also accepted. Is this point clear? You can notice triple A is also accepted. Tell me, triple A. Is triple A accepted? Yes. See what you can do. You can read this A, then you can go for free. Again, you can go to P. See what you can do. Triple A is accepted. What you will do? First, you will read this A and you will go to Q. Now, from this Q, for free, you can go to P. From this state Q, without reading any symbol, without reading any symbol. This means without reading any symbol. This means without reading any symbol. This is your null move. Yes or no? This is your null move. Means without reading any input symbol, you can go. So from this state Q, without reading any symbol, you can go for free to P. Yes or no? First you can go to R, then you can go to P. Then in this state P, you can read this symbol A. You can go to Q. Again, what you can do? From this Q, for free, you can go to P. From this Q, for free, you can go to R. And from this R, for free, you can go to P. So you can go like this. You can go like this. Then finally, here what you can do? Here you can go to final state. So this is also accepted. Okay. So I can say this triple A is also accepted. Similarly, the 4A also will be accepted and so on. What is the language of this NFA? What is the language of this NFA? That is your A plus. So what is the complement? The question is asking the complement of this language. What is the complement of this language? This is the complement. This string is not in the language. Yes or no? In this language, you don't have empty string. So the complement will be this. So your final answer will be what? The final answer will be this. Your final answer is going to be this. Tell me, did you understand? Very simple question, right? Yes or no? Now let me ask you one thing. Do you remember that what is DFA complement? Tell me, what is DFA complement? For example, basically I am saying that, do you remember we have already seen that if you have a DFA, D, in this DFA D, let's assume the language is L. You have a DFA and the language is L. You tell me one thing. If I make all the final states, if I do this, that all the final states, if I make them non-final, all the final states, I make them non-final, and all the non-final states, I make them final. Means I complement the states. What I'm doing? I am complementing the states. Yes or no? Agree with me? I am complementing the states. I am complementing the states. Means if you are a final state, I will make you non-final. If you are a non-final state, I will make you final. I am complementing the states. Now in this situation, you will get a new DFA. What you will get? You will get a new DFA. A new DFA, let's call it new DFA. Let's call it anything. For example, Let's call it T. A new DFA T you are getting. Tell me what will be the language of this new DFA T? What will be the language of this new DFA T? That will be L complement. Yes or no? Is this point clear? This we already know. If you have a DFA whose language is L, so what you do, you complement the states. You complement the states. Every final state, you make it non-final. Every non-final state, you make it final. If you do this, you will get a new DFA. You will get, let's call it T, new DFA. The language will be L complement. Can I say the same thing for NFA? Can I say the same thing? Can I say for NFA? Means if you have an NFA, if you have an NFA N, let's assume you have some NFA N, the language is L. If I complement the states, final states, I make them non-final. Non-final states, I make them final. If I complement the states, then can I say that new NFA will also accept L complement? This is wrong. Okay, new NFA will accept L complement. This is wrong. So let me tell you, okay, this will not happen. This may or may not happen. So finally, I am saying that if you complement the states in NFA, then the language may or may not complement. Is this point clear? In any NFA. So remember this. So please understand that this may or may not happen. So this is the final thing that I want to say, that in NFA, if we complement states, means what it means? If we complement states, what it means? Tell me what it means. It means I make all the final states, I make non-final, and all the non-final states, I make them final. Okay, so in NFA, if we complement states, then new NFA may or may not recognize L complement. Is this point clear? The new NFA may or may not recognize L complement, means the new NFA language may or may not be L complement. Okay, so let me give you a proof. For example, consider this NFA. First of all, you tell me, is this DFA or NFA? This machine, is this DFA or NFA? Yes, this is NFA. Because you can notice from this state A on 0, you have more than one transitions. From this state A on 0, you can go to A or you can go to B. So this is NFA. Now you tell me, what is the language of this NFA? What is the language of this NFA? This NFA. It is, I can say, the third symbol from right is 0. Yes or no? The third symbol from right is 0. Anything can come. See, notice what is happening here. Anything can come. If you notice, whatever comes, here anything can come. 0 or 1, 0 or 1, 0 or 1. Any string can come. Here any string, anything. And then 0 should come. And then two symbols should come. 0, 1, 0, 1. So, okay, two symbols should come. So can you notice this M3? That is your third symbol from right is 0. This is your third symbol from right is 0. Is this point clear? Please tell me. Did you understand the language? The language is third symbol from right is 0. This is your language. Now you tell me, if you complement the states, now what I do, we complement states. So this is what you do. You just complement states in M3. Okay. First of all, what it means? Complement states. When I say complement states, what I mean? This is not a standard word. This is not a standard terminology. So it simply means final, non-final, make non-final, final. So this means, remember, final, non-final. All the final state, you make them non-final. All the non-final state, you make them final. This is what it means. This is what it means. So now you tell me, if I do this, new NFA will be created. A new NFA I am getting. I am getting a new NFA. This new NFA you got. Okay, let's call this new NFA N, or you can call it new NFA T. So now you tell me, this is the new NFA T. What is the language of this new NFT? Tell me. What is the language? Can anyone tell me what is the language? The language is sigma star. Actually, if you notice, every string is accepted. What is the language of this new NFT? That is your sigma star. Every string is accepted. In this state, you can accept every string. Every string is accepted. Every string is accepted. Every string accepted. So tell me, can I say this is complement of M language of previous NFA? This is your previous NFA. This is your previous NFA whose language is this. Third symbol from right is 0. This is your previous NFA. So can I say, if I complement the states, the new language is sigma star. Is this complement of the previous language? The new language is sigma star. Is this complement of the previous language? No. Okay. So is this idea clear? So in NFA, you cannot make non-final state final and final non-final to get a complement of the language. Please tell me, did you understand this? So you can read this. How to complement NFA. This article you can read. This is from Standard University. This is a standard article. You can read this yourself. So what I want to tell you that if you want to complement a language, to complement a regular language, just give me a second. Okay. So to complement a regular language, if you want to complement a regular language, then tell me what you can do and what you cannot do. To complement a regular language, L. Let's assume you have a regular language L. What you can do, you cannot do. So you can notice that if you want to complement a regular language, then you can create a DFA, and in that DFA, you can complement the states. Okay. So what you can do for this language L, you can create a DFA. You can create any DFA M, or you can create any DFA D. Create any DFA. This can be any DFA. This can be any DFA. In this DFA, what you can do? You can complement the states. In this DFA, you can complement the states. You can complement states. And what that means? Complement states. That means every final state, you make it non-final. And every non-final state, you make it final. You complement the states. So like this, you will get a new DFA. Like this, you will get a new DFA T. And remember the language of this new DFA, what that will be? That will be L complement. The language of this new DFA will be L complement. Is this point clear? Please tell me. Let me know. So now you can notice one more thing. If you create NFA, let's assume you create NFA. Okay, you create this NFA N. You have some NFA N. In this NFA, if I complement the states, you will get a new NFA. You will get a new NFA. Let me tell you, this new NFA language may or may not be same as L complement. Okay, may or may not be same as L complement. Is this point clear? So let me know. So this complementing states, to get complement of language, complementing states to get complement of language, it works only for DFA. Okay, so remember this point. Complementing states to get language complement, language complement only works for DFA. May or may not work for NFA. May or may not work for NFA. Understood? Is this point clear? Let me know. So complementing states to get language complement, to get language complement only works for DFA, may or may not work for NFA. So this is an important point. Tell me one thing, why it happens? Why for NFA it does not work? Can anyone tell me? Like without example, can you tell me why? Why? What is the reason? Why for NFA it does not work? For NFA, complementing state may not work. Complementing state may not work. May not work. Can anyone tell me? What is the reason? Let me tell you the reason. Okay, I am giving you the reason, remember. So now I will not give you the example, I will give you the actual reason. So please focus here. You will find out why it happens. Why for NFA complementing states may not work. Complementing states may not work. Because you can notice, see, let's assume you have NFA N and this NFA N accepts W. Let's assume that there is NFA N which accepts W. Okay. Then what it means from the initial state on W, where you will go? Tell me. Please tell me. You have NFA N which accepts W. So what it means? What it means? In this NFA N, from initial state, where will you go on W? Where will you go on W? See, you can go to multiple states, very good. Okay, you can go to state 1, which is final. You can also go on W, you can also go to state 2, which is non-final. You can also go to state 3, which is a non-final. Agree? Do you agree with me? Okay, which is a non-final. Is this point clear? Now, if you complement the states, then will W be accepted or not? In this situation, if I complement the states, see, W is already accepted by N. You can notice W is already accepted by N. So this NFA, it is accepting W. Now, if you complement states, new NFA will accept W or not? Now, if you complement states, what will happen? New NFA will also accept, yes or no? New NFA will also accept W. Accept W. New NFA will also accept W because of 2, 3. See, the new NFA will be like this. Your new NFA will be like this. Your new NFA will be like this. Yes or no? Is this point clear? See, your new NFA will be like this. Now your new NFA is also accepting because of 2, 3. So now this idea, is this clear? Without example, can you intuitively see that for NFA complementing states may not work? Now can you tell me, complementing states in NFA, you complement the states, it will not work. It may or may not work. But without example, this is the actual reason. This is the actual reason why it happens. Please tell me, did you understand why it happens? Did you understand? Now tell me one more thing. One more question I want to ask. Let's assume you have some NFA. Okay. And this NFA is accepting the language L. Now you tell me, I complement the states in N. What I do? I complement states in N. Okay. I complement states in N. And by complementing states in N, I get a new NFA. I get a new NFA T. Okay. Now you tell me which is true. Which is true? Which statement is definitely true? Means which is definitely true? The first thing I am asking, that is language of this T, this language of this new NFA T, that will be L complement. This is the first option. Second option, language of this NFA T, that is subset of the language L. The language of this NFA is superset of this L. So tell me what will happen. LT is superset. It's superset of L complement. Fourth, LT, and they have nothing common. LT, L, their intersection is phi. Their intersection is phi. So means tell me which option is definitely true. Tell me which option is definitely true. Which option you can say is definitely true? None of the options is true. None of the options is definitely true. None of the options is definitely true. Because remember this always, this point you always remember, but that in NFA, if you are accepting, for example, W, you are accepting like this. Okay. On W, you are going. Now you can notice if you complement, okay, in this state, now if you complement the states, this is your NFA-N. This is your NFA-N. And this is your NFA-T. So your NFA-T will be like this. Your NFA-T, that will be like this. So you can notice here also W accepted, here also W accepted. Okay, here also W accepted, here also W accepted. Is this point clear? Please tell me. Okay, so this is the point. Very simple. Here also W. You tell me one more interesting thing. Let's assume here also W not accepted. If W is not accepted, please tell me, if W not accepted by N, then what will happen? If W is not accepted by N, can I say T will definitely accept W? Can I say? Did you understand my question? Question is very simple. This is my question. You have NFA-N. There is NFA-N. Okay. And you complement states and you get new NFA-T. You get a new NFA-T by complementing states. If you complement states. Now I'm asking, if W does not belong to L of N, then can I say that W will definitely belong to L of T? Please tell me. Please tell me. If W does not belong to L of N, can I definitely say that W belongs to L of T? First of all, you tell me in the NFA, if W does not belong to L of N, what it means? First of all, you tell me in NFA N, W does not belong. W does not belong. What it means? What type of diagram you will get? Tell me what type of diagram you will get. Can I say you will definitely get this type of diagram that on W, you will go to non-final state. Okay, every state will be non-final. Wherever you go, that will be non-final. Yes or no? Everywhere you go, that will be non-final. So if I complement the states, W should be accepted. Yes or no? So if I complement the states, this is your NFA-N. So if I complement the states, W will be accepted. So is this reason clear? Is this reason correct? Is this reason correct that W will be accepted? So can I say if NFA-N does not accept W, can I say NFA-T will definitely accept W? Can I say? So can I say this statement is true? This statement, is this statement true? Let me tell you, this statement is actually false. This statement is also false. But what is the problem? Is there anything wrong in this logic? Is there anything wrong in this logic? NFA-N does not accept W. So on W, you will go to non-final, non-final, non-final. In this NFA, you will go to non-final, non-final. So what is wrong in this logic? From this logic, it looks like W belongs to a language of T. What is wrong here? What is wrong here? Please tell me. What is wrong here? In this diagram, what is wrong? What is wrong? Let me tell you, there is something wrong in this diagram. And that is, it is not necessary that on W you go to somewhere. NFA has no move also. NFA has no move also. No move facility. NFA does not read the, and it is not necessary that NFA will read the entire string. NFA has no move feature. NFA may not read the entire string. NFA may not read entire string W. Yes or no? Please tell me yes or no. For example, let me give you one example. Consider this NFA. I am giving you state 1. If A comes, you go here, here. Okay, if B comes. So this is your state 2. Tell me, if I give you this W, B, A, B, A, A, tell me where this NFA will go from the initial state, where the NFA will go on this string. From this, on this string, where NFA will go? Tell me. Where NFA will go on this string? From the initial state, on this string, this is your string B, A, B, A. Where NFA will go? Nowhere. Yes or no? Nowhere. Are you getting this point? NFA has no move facility also. NFA has this facility, no move. Because in the state 1, in this state 1, you cannot even read B. You cannot even do that. Yes or no? Agree or not? No move. There is no move. So please tell me. So there will be nothing here, nowhere. Is this point clear? Now can you notice what is wrong with this logic? Now can you notice what is wrong with this logic? Yes or no? Please tell me, did you understand? What is wrong with this logic? Did you understand? So I am saying that, remember, so this is a note that in NFA, for example, let's assume you have some NFA N. In NFA N, if W does not belong to L of N, then don't make this diagram. See, what are the possible diagrams? What are the possibilities? Tell me, what are the possibilities? See, the possibilities are these. Either this will happen that from the initial state on W, wherever you go, that will be non-final. Either this possibility will happen. Agree? Agree? Wherever you go, that will be non-final. Either this possibility will happen, or this possibility will happen that there is no move. Nowhere. Is this clear? Let me know. So these are the possibilities. So that is the reason. Remember, this statement is also false. If W does not belong to Ln, then W belongs to Lt. That statement is also false. So can you notice, if you complement the states in NFA, you cannot say anything about any string. This is the final conclusion, very important conclusion, that if you complement the states in NFA, you cannot say anything about any string. You cannot say anything about the language. Please tell me, absolutely nothing you can say. So remember, this is very important that if you complement the states of NFA, okay, if we complement states of NFA, if we complement states in NFA, absolutely nothing can be said about any string. Is this idea clear? Please tell me. If we complement states NFA in NFA, then absolutely nothing we can say. Absolutely nothing. Nothing. Absolutely nothing can be said for any string and language. For any string and language. You cannot say subset, superset. Okay, you cannot say anything. Is this point clear? Please tell me. Absolutely nothing. There is nothing which you can say for certain. Is this point clear? There is nothing you can say for certainty. There is nothing you can say that will always be true. There is nothing. So please understand, because in the GATE exam, they can create this type of questions. See, in the GATE exam, if they create this question on your screen, W does not belong to NFA N. W does not belong to this NFA. Then many students, what they will do, in their mind, this type of diagram will come. Yes or no? Many students, they will think that on W, I will go to non-final. So if I complement the states, then W will be accepted. Yes or no? This type of diagram will come to mind for many students. But the point is, in NFA, you have this no move facility, no move feature. So this, just remember this point. This slide you remember. If you complement the states in NFA, then absolute nothing can be said for any string and language. I hope all these points are clear. Let me know. Now let me tell you something interesting. Something very interesting. This is your GATE exam question, right? Yes or no? Now, can you see this question is actually very simple? For this question, all you need to do, just find the language and complement it. Complement of the language, the question is asking complement of the language. This is your NFA-N. The question is asking you find the language and then you complement. So can you tell me the question is easy or not? Please tell me. This GATE exam question, this is easy or not? But let me tell you, if you go to this question on the GATEOverflow website, a lot of discussion is there. Can you tell me why? For such a simple question, this is so simple question, still there is a lot of discussion. There is a lot of discussion on this question. Many students, they find this question complicated. This question is very simple. You just find the language from this NFA, you find the language that will be A plus, you find the complement that will be set containing empty string. But still there is a lot of discussion. And let me tell you what is the reason. The reason is what many students are doing, they don't read the question. This is the habit of many students. Okay, they don't read the question. They see, okay, NFA, this word they will see. See, they will see this word, they will see this word. Then what they will do? Then they will do this. Okay. This is the habit of many students. Let me tell you, most students who fail in the exam, they have this type of habit. They don't read the question carefully. Many students who will fail in the GATE exam, many students, they will not read the question carefully. They will read the words. For example, they will read this word. See, I'm telling you, from their eyes, they can see this word. They will see NFA. They will see complement. They will not see the remaining words. They will not see these words. They will directly do this. Now you tell me what is the answer. They will do this. Means they will complement the states. They will complement the states. They will only see these two words. They will only see these two words. Basically, they will only see these two words, complement NFA. These two words they will see, this word, this word. Then they will complement the states. Okay, all the states they will complement. Now you tell me what is the language. Now can anyone tell me what is the language? Now if you notice, the language is A star now. And what will be the, okay, so this is the language. So you can notice, now the new language is A star. So they will say the answer is A star. What they will do? They will say the answer is A star. So please tell me, did you understand the thinking of majority of students? Now you might be thinking, sir, why would they do it? They can read the question carefully. The question is simply asking complement of language. The question is simply asking complement of language. But anyway, so I just want to tell you that complement, if you complement the states in NFA, nothing can be said. Is this point clear? If you complement the states in NFA, then you can say nothing for any string or language. Okay, let's move on. So this is the complete analysis of this question. A very, very simple question, but students make it complicated. Now let's see this question. This type of question we have done, right? So let's see this question number 12. This question is taken from ISRO. Again, let me tell you, sorry, NILIT. This question is taken from NILIT. So this is your language for strings are given to you. This question is taken from NILIT exam, NILIT 2018. Actually, these NILIT people, they have taken this question from the GATE exam. These NILIT people, they have taken this same question from the GATE exam, but what they did something extra. They did this ABA, BA, they did this, just B triple A, you know. So these NILIT people, they have taken this question from this GATE question, but in the GATE question, you have AB, AA, BA, and in this NILIT question, you have B triple A. That is the change. Okay. So anyway, and do you remember this GATE question is taken from where? Do you remember this GATE question is taken from where? This is as it is taken from Peter Lynch. This is as it is. Let me tell you, not even a word changed. The as it is question, all the options, everything is same. This question as it is taken from Peter Lynch. Okay, please mark this word, as it is. Nothing is changed. These are also same. These are also same. This line is also same. Everything is same. As it is, this question is taken from Peter Lynch. Anyway, so can you solve this question? So let's solve this. You can read for this gate question. I have already provided the video solution, right? For this gate question, you can check the video solution is already provided with complete explanation. Okay, the complete video solution, I can say everything is there. So you can check it out on the GATEOverflow website. You can check it out. This gate question, go to the GATEOverflow website. You can find my answer. In that answer, you can find the video solution. This video solution you can find. Okay. Now let's see this NILIT exam question. So let's quickly solve it. So tell me, in the language you have these strings. Which of these strings belong to L star? Which of these strings belong to L star? So tell me, which string belong to L star? Do you remember one thing? If your language L has these strings, for example, A, B, or maybe I can say W1, W2, W3. If your language L has this type of strings, what strings L star will have? What strings L star will have? If your language has these strings, W1, W2, and so on. So what strings belong to L star? Any combination of these, yes or no? Yes or no? So in this L star, you will have every combination of these. You will have lambda, you will have W1, you will have W1, you will have W1, W2, you will have W1, 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 you will have W2, W1, you will have W1, W2, W3, W1. Okay, basically any combination of these, yes or no? So can I say in the L star, you have every combination of Wi. Remember, you have every combination of Wi's. Okay, very simple. This point we have already seen. Anyway, now let's see this. So tell me, can you break down this string so that every part belongs to this L? Okay, remember one more thing I'm telling you. Again, I'm telling you, in this L star, whatever string you have, in this L star, if you take any string, if you take this string, then remember this point, you look at this string in L star. So this string, you can break it so that every part belongs to L. Is this point clear? In this L star, you take any string in this L star, that string can be broken so that every part belongs to L. So that every part belongs to L. So this is the idea. So you tell me in this question, this string, can I break it so that every part belongs to L? So let's check BAA. So first you tell me, initially, what are the possibility? Can I use these for the first part? For the first part, can I use these? I cannot use these for the first part. For the first part, I need to do this. This is the first part. Okay. What is the second part? What is the second part? There is no second part. Yes or no? So this string does not belong to the L star. Because you cannot break it down so that every part belongs to L. This string, we cannot break it so that every part belongs to L. So very simple. Tell me about this one. A, B, this one. Again, you can notice I can use this part, then I can use this part, but again, this part, this does not belong to L. So this also does not belong to L star. What about the next one? What about the next one? BAA, then BAA, sorry, B4A, then B2A. Okay, again here, you can create this part. You can create this part also, you can create. Then you can create AB, then you can create A. So this will be accepted. This will belong to L star. What about this one? BAA, BAAA. What about this one? So here you can notice this and you can notice this. So this also will be there. So number of strings that are in L star, the answer will be 2. The answer is going to be 2. So very simple, this type of question. Now let's see this question. This is your question number 13. Let me tell you, this question is taken from UGC NET. This question is taken from UGC NET. You can check it out. The same question as it is taken from UGC NET. Now, in this question, the question is simple. This machine is given to you. You can see this is Moore machine. The question is saying Moore machine, but actually we will study this in digital logic. Mealy machine, Moore machine. In digital logic, we will study what it means. Moore machine, Mealy machine. For now, you can understand that these are just finite automata. Okay, Mealy machine, Moore machine, these are similar to finite automata. Okay, this Mealy machine, Moore machine, these are similar to finite automata. So now you tell me what will be the answer for this question. So this is your UGC NET question. This machine is given to you. Is this DFA or NFA? This machine, yes, this is DFA. This is deterministic finite automata. The question is asking what is the language. So tell me what is the language. The language accepted by this machine. You can see. First of all, you tell me what is the initial state. See, many students, they commented that what is the initial state. Can you notice there is no initial state in this question? Now, some students, they commented that this question does not have initial state. Now, have you seen that in Go classes test, in the Go classes weekly quizzes, the questions are well framed. We don't make this type of mistake that there is no initial state. But still, intentionally, I did not give you initial state. Can you tell me why? Intentionally, I did not give you initial state. The reason is simple, because I wanted you to try this question, because this question has come in the UGC NET exam. So this type of question can come in the exam, right? Where you have to use your common sense. Yes or no? See, this type of question can come in the GATE exam also. Sometimes it will happen. There will be some mistake in the question. In the GATE exam also, this type of question can come. Okay. So in this question, you can use your common sense and you can see that from the options, you can find it out that yes, S0 is the initial state. Yes or no? Is this point clear? See, in this question, initial state is not given. Now, from the options, from the question, you can easily find out that S0 must be the initial state. So this is your initial state. Now you tell me what is the language. You can notice any number of A, ignore. Any number of A are coming, ignore. Then B should come. Then B should come. Then any number of A come, ignore. Any number of A come, ignore. Then B should come. Then B should come. Then anything can come. Then anything can come. Okay, it means any number of A, B should come. After that, B should come. Then any number of A, then after that, B should come. Then anything can come. Then anything can come. Okay, very simple, right? So definitely I can say contains at least 2B. There should be at least 2B, 2 or more B's. So the answer will be option A. There should be at least 2 B's. You can notice at least 2B. There must be at least 2B. After that, anything can come. So very simple. So this is your answer, 2 or more B's. Very simple question. Let's see this question. Question number 14. Before we discuss this question, let's discuss question number 15. Let's see this. Question number 15. Tell me the answer. This question number 15, this is taken from UGC NET. This is another question from UGC NET. The question is very simple. Alphabet is given to you, that is A, B. Language is given to you, that is A, B. Okay. So your language is basically AA, B. This is the language. The question is asking what is the complement of this language. So tell me what is the complement of this language. If your language is AA, B, complement means all the strings which are not in L, right? All the strings which are not in L. Yes or no? So tell me which strings are not in L. L complement. So you can notice which strings are not in L. I can say, see, this string is not in L. This string is not in L. This is not in L. This is not in L. This is not in L. And you can notice that every string of length greater than equal to 3 is not in L. Every string of length greater than equal to 3, that is not in L. Okay, is this clear? So very simple, this is your answer. So you can notice these strings, they belong to L. So which strings are not in L? These strings are not in L and these strings are not in L. So your answer will be this. So your L complement will be These strings union all the strings whose length is greater than equal to 3. So answer will be option D. So very simple question. Now let's come to this question. Question number 14. This question number 14. This question is taken from UGC NET. The question is asking number of finite automata. How many finite automata are there? So let's do the complete analysis of this question. Okay, see this. This question, our weekly quiz question number 14, that is taken from UGC NET. Okay, so let's do the complete analysis of this question. The question is asking, there are exactly these many different finite automata with 3 states x, y, z over the alphabet a comma b, where x is always the start state. So this is the question. The question is asking how many finite automata are there. Okay, so let's do the complete analysis. So don't worry, we are going to do the complete analysis of this question. Don't worry. So let me ask you one thing. Okay, so you tell me one by one, you tell me. Let's assume that you have these states. I am giving you states. So let's assume states are these. States Q. And let's assume states are X comma Y. Let's assume these are the states. Okay. And your alphabet is, let's assume A comma B. These are the alphabet. This is the alphabet. Okay. Now you tell me how many DFA are there? How many DFAs you can create? How many DFAs I can create? How many DFAs are there? How many DFAs I can create? So let's see. Okay, so please understand, I am telling you states are X comma Y. These are the two states, X comma Y. And alphabet is also given to you A comma B. Okay, now the question is asking how many DFAs. Let's assume initial state is X. Let's assume initial state that is X. So tell me how many DFAs will be there. So you can create many different DFAs, right? See, you have two states, X comma Y. Initial state is X. You can create many different DFAs. What you can do? You can create, for example, you can create this DFA. Yes or no? You can create this DFA. Now you can notice in this DFA also, what you can do? Maybe you can make this final state, or you can make this final state, or you can make both of them final state, or you can make none of them final state. So can you notice this means 4 DFA? Yes or no? Can you notice this means basically here you can create 4 DFA? Yes or no? I am asking a new question. See, one by one, step by step, we are going. At the end, we will solve this question. This question we will solve at the end. Okay, so forget about this question. I am asking you, assume that states are X comma Y. These are the states. Alphabet is A comma B. Let's assume initial state is X. How many DFAs are there? So can you notice this DFA you can create? Many more DFA you can create. In this, you can create total 4 DFA. You can make none of them final state. So you will get this. Or you can make this final state. Or you can make this final state. Or you can make both of them final state. Similarly, you can get this DFA also. Initial state is this. I can do this also. Is this a DFA? Tell me. Tell me, is this a DFA or not? Is this a DFA or not? Tell me. Yes, this is also a DFA. No problem. This is unreachable state. This is also a DFA. So like this, you can create many DFA, right? Like this, you can create many DFA. So how many DFA you can create? How many DFAs basically you can create? The answer is, tell me one thing. What you need? You already have X. You already have Y. Okay. You already have X. You already have Y. Your alphabet is A comma B. You tell me one thing. What do you need to create a DFA? What we need to create a DFA? We want to create a DFA. What we need? What we need to create a DFA? Tell me. To create a DFA. Already you have X comma Y. These are the two states. And alphabet is A comma B. What we need to create a DFA? If you want to create a DFA, what you need? Two things you need. One thing is transitions. One thing is transitions. The second thing is set of final states. Yes or no? Do you agree with me that you need two things? One is transitions. The second is set of final states. Okay, so now you tell me how many transition functions you can create. Remember your DFA transition function. What is that? DFA transition function. DFA transition function, what it will do? What it will do? You know what it will do? The domain is Q cross sigma to Q. Yes or no? This is the DFA transition function. Means in any state, what symbol comes, then you will go to some state. Is this point clear? See, very simple. This is your DFA transition function. Your input is you are in some state, some symbol comes, then where will you go? Then where will you go? So this is your DFA transition function. Now you tell me, already Q is x comma y. Your set of states, that is x comma y. Your alphabet is a comma b. So tell me how many transition functions you can create. How many transition functions you can create? So here you have x comma a, x comma b, y comma a, y comma b. So tell me how many transitions you can create. Means how many transition functions you can create. Tell me. From this to this, how many transition functions I can create? This is your Q cross sigma. This is your Q. So tell me, what are the number of transition functions? Number of transition functions. How many different transition functions I can create? How many different transition functions I can create? That will be 2 power 4. That is your number of functions. How many functions you can create from this set to this set? How many functions? So 2 power 4, that means 16 functions you can create. Yes or no? So you can notice basically transitions we need to create. So number of transition functions. Number of transition functions. How many transition functions are there? Number of transition functions, that will be 2 power 4. Okay. So once I create transitions, for example, let's assume I create these transitions. I create A here, I create B here, I create A here, B here. Okay. So once I am done with this, these many transition functions I can create. So once I have created transitions, now you tell me how many choices for final states. Tell me how many choices for final states. You know, set of final states, that is subset of Q. That is subset of Q. Any subset of Q. That is subset of Q. Any subset of Q. Any subset of Q. So how many subsets of Q are there? How many subsets of Q are there? That is 2 power 2. That is 4. Yes or no? That is 4. 4 subsets are there. Is this point clear? So once you create the transitions, now you need to decide who will be the final state. Once you create the transitions, now you need to decide who will be the final state. So tell me, this is your Q, x comma y. This is x, this is y. Tell me, what are the possibilities for final states? What are the possibilities for set of final states? What can be the set of final states? Don't create any final state. So this is possible. Don't create any final state. Or you make this final state, then this is possible. Or you make this final state, then this is possible. Or you make both of them final state. Or you make both of them final state. Then this is possible. So how many? Tell me. Set of final states. How many possibilities? Set of final states. For final states, how many possibilities? 2 power 2. 2 power 2. It's like this. Either this state you can make it final or not make it final. Make it final or not make it final. Yes or no? Are you getting my point? So for final state, every state has 2 choices. Yes or no? For final state creation, for final states creation, every state has 2 choices. Every state has 2 choices. Every state has 2 choices. Either you make it final or don't make it final. Either you make it final or don't make it final. Every state has 2 choices. So is this clear? So finally you can notice every state has 2 choices. So 2 power 4. These many possibilities for set of final state. And these many transition functions are there. So how many DFAs you can create? So tell me the number of DFAs. How many DFAs you can create? That will be 2 power 4. This is the number of transition functions. This is the number of transition functions. This is the number of transition functions. How many different transition functions you can create? Multiplied by 2 power 2. This is for final states. This is for final states. So your answer will be 2 power 6. That means 64 DFAs you can create. 64 DFAs you can create. Please tell me, did you understand? See, 64 DFAs you can create. You can keep creating the DFAs. You can create total 64 DFAs. Just keep creating the DFAs. For example, you can create this type of DFA you can create. Okay, this is also counted. This DFA also we have 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 counted. Are you getting my point? Yes or no? So you can keep creating the DFAs. For example, this DFA also you can create. These are different DFAs. The DFAs are different. This also we have counted. Okay. For example, you can create many more. You can create many more DFAs. For example, you can create this DFA. Okay. Are you getting my point? Is this point clear? Total how many? If you do like this, how many DFAs you can create? How many DFAs you can create? 64 DFAs you can create. If you do like this, 64 DFAs you can create. Please tell me, did you understand this question? This question, did you understand? Let me know. Now let me tell you something very nice. That see, whatever I ask you, if you see DFA, whether you see NFA or whether you see PDA, Turing machine, whatever, okay, whatever, DPDA, whatever, in all these machines, these are automata. All these are automata. We will study this PDA, we will study, don't worry. But in these, in all of them, what is the most important part? For example, in a car, what is the most important part? If you have a car, in this car, what is the most important? In this car, you have many things. You have steering, you have tire, okay, you have chassis, you have many things. What is the most important? The most important is engine. This is the most important, right? Similarly, so if I say car is DFA, then in DFA, what is the most important part? In the DFA, what is the most important? Means who is the engine of DFA? Who is the engine of DFA? Who is the engine of DFA? That is transition function. That is transition function. Who is the engine of NFA? That is transition function. Who is the engine of PDA? That is transition function. So transition function is the most important. Similarly, so this is what I'm saying. So if I tell you how many DFAs, basically what I'm asking. So if I ask you number of DFAs, basically what I'm asking how many transition functions are there. Is this point clear? Means when I say how many DFAs are there, it simply means how many transition functions. We are mainly interested in the transition functions. Okay, we are mainly, this is the important. We are mainly interested in the transition functions and some other things like final states. Yes or no? Some extra things multiplied by final states means for final states, set of final states. Yes or no? Something like this. Is this point clear? So the main important, this is the main driving factor, the transition function. Similarly, if I tell you how many NFAs, then also number of transition functions. Similarly, if I tell you how many PDAs, then also the number of transition functions. Is this point clear? So these are the importance. Now let's see for NFA, for DFA, everything. So you tell me, let's see the generalization, number of DFAs. Let's see the generalization, number of DFAs. Okay. So let's assume that you have set of states. Your set of states is 1, 2, 3, and so on. And this is the set of states. Let's assume this is the set of states. Now, in this set of states, and these are labeled. Remember, let's assume these are the labeled set of states. These are the labeled set of states. Okay. So in this, let's assume your alphabet is A, B, C, and so on. Something like this. So let's assume your alphabet size is, let's assume M. Size of alphabet, let's assume that is M. Okay. So now you tell me, if I give you initial state, this is given initial state is 1. Okay, if initial state is already given to you, initial state is 1. Now tell me how many DFAs are there? What is the number of DFAs? How many DFAs you can create? What is the number of DFAs? See, initial state is 1. This is the initial state. Okay, alphabet size is M. So number of DFAs, what that will be? Very simple. Number of DFAs, what that will be? Just find out how many transition functions are there. That will be number of transition functions. Just find out how many transition functions you can create. How many transition functions you can create multiplied by set number of possibilities for final states. Number of possibilities for final states. Okay, so tell me how many transition functions you can create. What will be the number of transition functions? Q cross sigma to Q. This is the transition function, right? Q cross sigma to Q. The size of Q you already know, that is N. What is size of Q cross sigma? What is size of Q cross sigma? Tell me, what is the size of Q cross sigma? That will be Mn. Yes or no? That will be Mn. Or I can say that will be Nm. Okay. So very simple. So tell me, how many transition functions are there? So number of transition function. That will be N power Mn. Yes or no? For simplicity, you call it Q. You call it Q only. Okay. It's like this. Q power sigma Q. Something like this. Yes or no? Q power sigma Q. Yes or no? So your transition number of transition function that will be N power Mn. That simply means Q power sigma Q. Something like this. Okay. Means size of Q power something like this. I hope this point is clear. And how many possibilities for final states? What are the possibilities for final states? Every state has two choices. Yes or no? Every state has two choices. Agree? Every state has two choices. Every state has two choices. You can make it final or non-final. Make it final or non-final. Make it final or non-final. So every state has two choices. So finally your answer is what? So number of DFAs. That will be size of Q power size of Q size of sigma multiplied by 2 power size of Q. Is this clear? This is your for transitions. This is for delta. And this is for set of final states. Will you remember this? Will you remember this? Tell me. Will you remember this? Don't remember this. Okay. Please don't remember this. Never remember this. Okay. So don't remember all these formulas that we are deriving. Just understand. Don't remember. Okay. Just understand. Just understand. Don't remember. Do not remember. Never remember. After this session, you forget about it. Okay. All these formulas you forget. But the logic you understand. The logic you understand. Okay. You can forget about the formula. Never remember the formula. You can just understand the logic. Okay. Is this clear? Please tell me how many DFAs you can create. That point is clear. Let me know. Now let me ask you one more thing. If initial state is not given, let's assume initial state is also not given. Initial state not given. Let's assume initial state is also not given. Okay, but you have labeled states. But your states are labeled. If initial state is not given, but your states are labeled. Now you tell me, if you have labeled states, now how many DFAs you can create? Same. For transition function, how many? For delta, what value you will get? Tell me. For delta, what value you will get? The same. Number of states power number of states multiplied by number of symbols in this sigma multiplied by for final states. For final states, that is 2 power number of states. Now, additional point is, see, For initial state, how many possibilities? Please tell me. For initial state, how many possibilities? For initial state, how many possibilities? N possibilities. Either this can be initial state, or this can be initial state, or this can be initial state. So N possibilities. So I can say it's like multiplied by number of states. So if initial state is not given, then you can multiply with number of states. When your states are labeled, when the states are labeled, is this clear? When the states are labeled, then you can do this. Now, if the states are not labeled, if the states are unlabeled, by default, states are unlabeled. Let me tell you, by default, in DFA, states are unlabeled. So let's assume you have these many states, means let's assume number of states is N. And let's assume that states are unlabeled. States are unlabeled. States are unlabeled. Okay. Which is by default. Let me tell you, this is by default. States are unlabeled. This is by default. Is this point clear? This is by default. This is the by default actually. Whenever you create DFA, tell me, the label of state, does it matter to you? The label of state, does it matter? Think about it. Whenever you create a DFA, you are creating a DFA, the label of the state, does it matter? No, it does not matter. Yes or no? The label is given for our convenience. Yes or no? When we create the label, I give the labeling according to what we have seen, what we want. Yes or no? Do you remember when we create the DFA? I give the labeling that what we have seen, what we want, what we have seen, what we want. So you can notice that is the reason I'm saying states are unlabeled. This is by default. By default, this is by default that states are unlabeled. In this situation, you can basically, you don't have to do this because initial state can be anything. Yes or no? In this situation, initial state, you can make anything initial state. Just make anyone initial state. Yes or no? In this situation, initial state, you can make any one of them. So in this situation, initial state, basically for the initial state, you don't have to multiply. Yes or no? Is this clear? For the initial state, you don't have to multiply because states are unlabeled. See, in the previous question, you can make this initial state, or you can make this initial state, or you can make this initial state. But if states are unlabeled, it's like everything is 1, 1, 1, 1. Now tell me, does it matter? Does it matter? If everything is 1, 1, 1, now does it matter? No. So you can notice you don't have to multiply this. Is this point clear? So in this situation, I can say initial state can be anything. Can be, it's like the initial state is, okay, choose any one of them as initial state. Basically, in this situation, initial state does not play any role. You can make any one of them initial state. Is this clear? But tell me, will final state matter? If your states are unlabeled, will this come? See what I am asking. I am asking that if your states are unlabeled, for example, let's assume you have 3 states. Now in this situation, because your states are unlabeled, see, I am not giving any labeling. Okay, so in this situation, initial state, you can make any of them. Means your starting point, you can make this. This state, you can make your starting point. Now you tell me, one thing I am asking. Let's assume I create some transitions. I have created some transitions. Let's assume there are some transitions. Some transitions are there. Okay, some transitions are there. Is this point clear? Some transitions are there. After creating the transitions, you tell me, does it matter? This is final state or this is final state. Are these two cases same? Are you getting my point? That these two cases are the same? That this case, is this case same as this case? Is this case same as this case? Please tell me. Are these two cases, are these two DFAs same? No. These two DFAs are not same. These two DFAs are not same. No, they are not same, because maybe, see, this is your initial state. Maybe this transition is A. Now these DFAs are not same. Can you notice? In this DFA, you are accepting A. In this DFA, you are not accepting A. So these two DFAs are not same. Is this point clear? So I'm telling you that when states are unlabeled, only initial state doesn't matter. Final state matters. Only initial state doesn't matter. Only initial state doesn't matter, basically. But remember, final state matters. Is this point clear? Basically, when states are unlabeled, then only initial state can be taken for granted. It's like this. Okay, only initial state can be anything. It's like this. Can be anything. Okay, can be anything. The starting point you can choose anything, but final state will matter. Please tell me, did you understand this? Let me know, did you understand this? So final state will still matter. The only point is you don't have to multiply for initial state. Means this multiplication you don't have to do. Let me know, did you understand? See, don't by heart. All these things, are they intuitive? All these things that we are learning, are you understanding? Don't rote learn. Don't by heart. Intuitively, are you getting? In the GATE exam, they can give you anything. In the GATE exam, they can give you any situation. They can give you a specific initial state. They can give you states unlabeled. They can give you states labeled. So they can give you any situation. Okay, is this point clear? Let me know. Let me know. See, here, did you understand this? I am telling you that if you have two unlabeled states, let's assume your language is this. Okay, just assume your language is sigma plus. Okay, let's create DFA. Let's create DFA. Okay, you have two states. I am telling you there are two states. Okay, two unlabeled states. There are two unlabeled states. Okay, there are two unlabeled states. Now, so these are the two unlabeled states. So what are the possibilities for DFA? See, either you can make this initial state or you can make this initial state. I just want to tell you that initial state you can make anything. Initial state you can start. See, you can start here or you can start here. But now you will get the same DFA. Please understand. See, you can start here or you can start here. Now let's create the DFA. Now let's create the DFA. This DFA you will get. Now let's create the DFA. This DFA you will get. Agree with me? What will be the final state here? Tell me. What will be the final state here? Here, what will be the final state? That will be this. So can you notice these DFA are same? Can I say these two DFA are same? Your language is sigma plus. Can you notice these DFA are same? For this language create DFA. Can you notice these two DFA are same? These are same DFA. So now did you understand that initial state you can take anything? Your initial state, you can start from any, see, it's like this. I give you an unlabeled states. Unlabeled states. I give you an unlabeled states. Now, when you are creating DFA for any language, you tell me, is it necessary you start from this? If I create DFA for any language, is it necessary I start from this? You can also start from this. These states are unlabeled. These states are unlabeled. Yes or no? Did you understand that starting point you can anything? You can choose any of them as starting state. Yes or no? Can start from anywhere. Can start from any of them. Or I can say can choose any of them as starting state. Can choose any of them as Q0, as your initial state. Please tell me. But don't take final state for granted. Don't take final state for granted. Why? What is the reason? See, if you take final state for granted, then what will happen? For example, what I am saying that, see, here you are making this final state, and in another diagram, Exactly same diagram. Transitions are also same. Everything is same. Everything is same. But if I make this initial state, are they same DFA? Here I am making this initial state. Here, sorry, here this is the final state. Here this is the final state. Notice, here this is your final state. And here this is your final state. Are they same DFA? Are they same DFA? They are not same DFA. So final state matters. Please tell me, did you understand? Now is this point clear? Now is this point clear to everyone? Please tell me. Let me know. So final state will matter. Final state will matter. Okay, if you make both of them final state, are these two DFA same? Are these two DFA same? No. Are you getting my point? If I make none of them final state, if I make none of them final state, so number of final state, that will be same, 2 power n. Every state has two choices. Every state has two choices. Either you can make it final or you don't make it final. Every state has two choices. Either you can make it final or you don't make it final. So when your states are unlabeled, then this will be your answer. Please tell me, did you understand? Let me know. Shall I move on? So this is your number of DFAs. Okay, when states are unlabeled, then your initial state, basically you can start from any state. Your initial state can be anything. Okay, let's move on. So these we have seen. So tell me finally, for DFAs, what is the conclusion? Let's see counting DFAs. Counting number of DFAs. Counting number of DFAs. Okay, you tell me everything. What we have seen, you just tell me. So counting number of DFAs, the first thing is, if I tell you this data I give you, number of states I give you n, number of symbols, number of alphabet symbols I give you m. Now, how many DFAs will be there? With this data, what your answer will be? With this data, what your answer will be? If your data is this, what your answer will be? See, by default, I told you states are unlabeled. Yes or no? You already know this point, that by default states are unlabeled. So you have n states and you have m alphabet symbols. So how many DFAs will be there? That will be very simple. For delta, what your answer will be there? For transition function. So the transition functions will be n power mn. This will be the transition function. Multiply by, for final states. For final state, every state has two choices. Either you can make it final or you don't make it final. See, these are the, let's assume number of states is 2. So for final states, what you can do? Tell me. See, initial state, you can make any of them. You can make any of them initial state. For final state, you have total 4 possibilities. This is one possibility. This is another possibility. This is another possibility. And this is 4th possibility. Is this point clear? Let me know. See, from this, I can say for final states, there are 4 possibilities. What are the 4 possibilities? This is one possibility. What is another possibility? This is another possibility. What is another possibility? This is another possibility. And what is another possibility? This is another possibility. Every state has 2 choices. Either you can make it final or non-final. Make it final or non-final. So that is the reason. So that will be 2 power n. Yes or no? And you know that by default, this is your default case. By default, unlabeled states. Is this clear? By default, unlabeled states. By default, the states are unlabeled. So this is your answer. Please tell me, did you understand? So this is your counting number of DFAs. Okay? Clear? Now let's move on. Now tell me one more thing. If your states I give you 1, 2, and so on, these are the states, means labeled, means you have labeled states. Now your answer will be what? Now your answer will be what? So now your answer, number of DFAs, that will be again For delta, you can find for delta it will be n power mn multiplied by, for final states it will be 2 power n, and for initial state it will be multiplied by n. Okay, so simple. For initial state you will multiply with n. So this is your answer. I hope all these points are clear. So this is your DFA, counting DFAs. Now let's count NFAs. Now let's see counting NFAs. Counting NFAs. So now you tell me. Again, the same thing, nothing will change, nothing will change. So you tell me, let's assume you have NFA. And in this NFA, number of states I give to you, that is n, alphabet symbols, that is m. Okay. So now you tell me how many NFAs are there? What is the number of NFAs you can create? Again, by default, states are unlabeled. So you don't have to worry about the initial state. You don't have to worry about the initial state, okay? Because states are unlabeled by default. So you can choose any of them as initial state. See, states are unlabeled. You can start from anywhere and then you can create your NFA. You can start from anywhere and then you can create your NFA. Okay, is this clear? So how many NFAs you will be there? In this NFA, the interesting thing is transition function. See, in NFA, the interesting thing is calculating delta, calculation of delta, yes or no? Basically counting number of transition functions. Counting number of transition functions. Counting number of transition functions. So tell me, in the NFA, what is the transition function? Tell me, what is the transition function in NFA? In NFA, what is the transition function? In any state, either you will read some alphabet symbol, or you will make, or you can make null move. Yes or no? Agree? Is this point clear? In any state, either you read some alphabet symbol or you make a null move to where? To where? Tell me. To 2 power q. You can make move to multiple states. You can make your move to subset of states. Okay, so very simple. This is the transition function. For example, in this state q, you can read symbol a and you can go to multiple states. You can go to q1, you can go to q2, you can also go to q. Something like this. For example, in this state, you can make null move. You can make null move. This is your null move. You can make null move and you can go to some states. For example, you can go to q1, you can go to q2. Yes or no? So this is your transition function. So tell me, how many transition functions are there? What is the size of this? Okay, tell me, what is the size of this? This will be 2 power n. Yes or no? Here there will be 2 power n because number of states are n. Number of states are n. And the size of sigma is m. Number of states, that is n, and the size of sigma, that is m. So tell me, what is the size of this one? That is q cross. Here you have how many? Tell me, here you have how many? Here you have how many? That is m plus 1. Yes or no? It's like m plus 1. So finally I can say it will be n multiplied by m plus 1. So how many functions will be there? So how many transition functions you can create? So the number of transition function, what that will be? That will be 2 power n multiplied by m plus 1. Yes or no? Is this point clear? Please tell me, is this point clear? So number of transition function, that will be 2 power n multiplied by n plus m. It's like this. So finally I can say the number of transition function. The number of transition function, that will be 2 power n multiplied by m plus 1. And that is same as what? Tell me. That is same as 2 power n m plus 1. And that is same as 2 power n square. Okay, so just leave it here. I think just leave it here. Okay, so like this. So it will be your 2 power n multiplied by m plus 1. So this is your number of transition functions. Is this point clear? Please tell me. Yes or no? Is this point clear? So finally your answer will be what? So number of NFAs, what that will be? What that will be? Number of NFAs, that will be. So for delta, you will have what? That you will have 2 power n multiplied by m plus 1 multiplied by for final states. For final states, tell me again the same. That will be same. Every state has two choices. Every state has two choices. So for final state, nothing will change. Okay. So this is your answer. This is your number of NFAs. Please tell me, did you understand? Let me know. Did you understand? Please tell me. This, did you understand? Now tell me one more thing. If I say NFAs without null move, if I say NFAs without null move, if I say NFAs without null move, now tell me what will be the answer. Now the answer will be just change this. Okay, this is the only change that will happen. This is the only change that will happen. If I say number of NFAs without any null move, then this is the only change that will happen. Now some of you might be thinking, what is by default? When I say NFA, do I mean NFA with null move or without null move? Tell me. When I say NFA, do I mean NFA with null move or NFA without null move? When I say NFA. So let me tell you something interesting here. Okay, this is one point. Have you seen in our lectures? Did you notice in our lectures, I use the word NFA. I don't use this type of word like epsilon NFA. Yes or no? We use this word. In our lectures, if you notice in our lectures, NFA has these facilities. NFA has null move facility. Agree with me? Yes or no? In our lectures, NFA has null move facility, no move facility, non-determinism facility. Agree? Okay. But let me tell you, there are some authors, for example, the most popular author, that is Ullmann. So if you study this Ullmann book, you will find that Ullmann book has two NFAs. There is NFA and there is epsilon NFA. Okay, Ullmann has two type of NFAs. One is NFA and another is epsilon NFA. So Ullmann, whenever Ullmann says NFA, he want to say that there are no null move. Okay, so these are the NFAs with no null move. These are the NFAs with no null move. With no null move. Okay, and these are the NFA with null move. These are the NFA with the null move. Is this point clear? And okay, this Ullmann book, if you study this book, then there are two type of NFA. One is NFA with no null move. There are no null transitions. There are no null moves. Another is epsilon NFA. But let me tell you, if you study any other book like Sipser, if you study Stanford TOC course, okay, if you study Sipser or you study Stanford 103 TOC course, it is a very popular course. Okay, if you study this course, if you study Sipser, this Sipser is also very popular book. Okay, if you watch the course of Sipser, there is a course also. If you watch the course of Sipser, that also you can watch. Or if you watch NPTEL, or what I have seen in ISC, okay, and most of the books, okay, majority of the book, I can say most of the books. In ISC Bangalore, I have taken this course. I took this Automata theory course. So in ISC, you can study Professor Deepak D'Souza slide, you can study. Deepak D'Souza. Okay, Professor Deepak D'Souza. So his course is there in ISC, Automata theory course. So in all these courses, if you notice, we are following these courses. In all these courses, in all of them, in all these courses, there is no epsilon NFA. Is this point clear? So most of the courses don't have epsilon NFA. Similarly, there is a book Cogen. This is a book very, very, I can say, advanced level book, you can call it. In MTech, you will study this type of book. Okay. In BTech, we study Ullmann. This type of book we study in in BTech. In MTech, you will study this type of book, Kozen. So what I'm saying, in all these books, these are same as our lectures are influenced by them. Is this point clear? In all these books, this word NFA contains everything. In all these books, this word NFA has null move also, no move also. Is this point clear? Means this word NFA contains everything. This word contains everything. Please tell me, did you understand what is happening here? Did you understand what I'm trying to say? Our lectures are also influenced by all these. Our slides are taken from Stanford article, Sipser. We are following basically these two. Also, Professor Deepak D'Souza ISC course. So basically, I am following these two. So I am saying that from these, our course, our lectures are influenced. Is this clear? Please tell me. Our lectures, they are taken from these courses. Okay, so you can easily notice that most of the time, most of the authors, most of the writers, most of the books, most of the courses, in those courses, this NFA word, it includes everything. It includes null move also. But you can notice Ullmann has two type of NFA. One is simple NFA and another is epsilon NFA. So did you understand what is happening here? It's author dependent, yes or no? It is depending on the author. Is this clear? Please tell me. So when I say NFA, okay, let's assume there is a exam. Some hulu exam is there. In some hulu exam, what will happen? In this hulu exam, they will give you this word NFA, okay, and they will ask you count number of NFAs. Count number of NFAs. Okay. See, let me tell you, but in any good exam, if it matters, I'm telling you, if this matters, then in any good exam, they will define it. They will give you proper. In any good exam, what they will do? In any good exam, all details will be given. Every detail will be given. All details given. Is this clear? Please tell me. Let me know. So don't worry about these things. Never worry about author dependent things. See, in every subject, whatever subject you take, computer science or without computer science, okay, in any area of study, there are always these type of things, author dependent. Okay, for example, this NFA. When I say NFA, do I include null move or not? Okay, when you say NFA, should we include null move? Should we consider null move or should we not consider null move? So this is author dependent. Please understand, this is author dependent. You can check it out. Ullmann says that when you use NFA, in the Ullmann book, whenever he uses NFA, whenever they use NFA, then they say that NFA means no null move. And if they want to include null move, then they will use epsilon NFA. This epsilon NFA they will use. But in other books, in Sipser, in Kozen, Sipser book, Kozen book, Stanford 103 course, that is a very popular course, you can check it out. IISc Deepak D'Souza Automata theory course. So all these courses, in all these courses, NFA means null move is included. Okay, NFA, in the NFA, null move is included. Similarly, in our lectures also, NFA means null move facility is there, no move facility is there, non-determinism is there. So please understand that for the author dependent things, don't worry. There is not a single gate question in which this matters. Please understand, this is very important. In the gate exam, in the previous year gate exam, there is not a single question in which this matters. So author dependent things, they do not matter in any good exam. In any good exam, author dependent things will never matter. Okay, you see in the test series, in some test series, they will ask you some question and then you will waste some time. Okay, you will say that NFA includes null move. Someone will say NFA does not include null move. Okay, so you will basically fight. Are you getting my point? Okay, you will fight. So that is what I'm saying. So don't worry about these things. In any good exam, these type of things will never matter. Author dependent things will never matter in any good exam. So don't worry about author dependent things. Again, I'm telling you, don't waste your time. I have seen students, they waste their time. They will write on the GATEOverflow, in the comments, they will write, okay, in my notes, this is there. In my notes, this is there. Okay, so please don't do that. So please understand that author dependent things, never worry about them. Is this clear? As a Go classes student, you should never worry about author dependent things. So just if the question in the test series, if such question comes in which it matters, author dependent things, they matter, then that question you can skip. That question you can leave. That is a very poor question, you can leave it. Okay. So I hope this point is clear. Okay, so let's move on. So is this clear? So how many NFAs are there? Is that idea clear? So please tell me, did you understand this? NFA without null move, what answer you will get? This answer you will get. And NFA with null move, you will get this answer. Please tell me, did you understand? Let me know. Okay. So very simple, you can check it out. So I hope all these points are clear. Now you can solve this question. Now let's come back to this question. Yeah, okay, so this is the question. So now let's see this question. So tell me, in this, can you notice there is a problem here? The question is saying finite automata. Do they mean DFA or NFA? Tell me. The question is saying finite automata. By default, finite automata means NFA. See, finite automata is a general word. In this finite automata, DFA also comes, NFA also comes in this finite automata. So when you say finite automata, DFA also comes, NFA also comes. So this is just a general word. I can say this is just a general word. Okay, so please understand that. So when you say NFA, when you say finite automata, then in this also comes, this also comes. There are two types of finite automata. Okay, but you can see from the options, this is your UGC NET question. If you are solving this question, then tell me how many DFAs will be there. You just tell me that. How many DFAs will be there? That answer you tell me. Please tell me. See, there are three states X, Y, Z. X is always the initial state. X is always the initial state. How many DFAs will be there? You have three states. Number of states are three. X, Y, Z. These are states. X is always the initial state. This X, this is your initial state. So how many transitions will be there? Tell me. For the transition function, what answer you will get? Alphabet is this. So your transition function will be like this. Q cross sigma to Q. So number of transition functions, what that will be? Tell me. Number of transition function, that will be Q. Size of Q, that is 3. 3 power 6. 3 power 6. Yes or no? So this will be 3 power 6. So remember, for delta, this will be the 3 power 6. Multiplied by, for final states. For final states, what you will get? Every state has two choices. Every state has two choices. So how many DFAs will be there? Tell me, how many DFAs will be there? So if you calculate, number of DFAs will be this. Now let me ask you one thing. Can you guarantee that number of NFAs will be definitely more than this? Can you say number of NFAs will definitely be more than this? See, number of DFAs you got, that is 5832. What will be the number of NFAs? Number of NFAs will definitely be more than this. So the question maker of this question, there is no option greater than this. Yes or no? Yes or no? There is no option greater than this. So what will be the answer? Tell me. There is no option more than this. So the answer will be this. Option D will be the answer. Because remember, the NFAs will be more than this. So the question maker, what the question maker is thinking? The question maker is thinking that finite automata means DFA. Okay, the question maker is thinking that finite automata means DFA. Is this clear? Now some students are asking, what if this is NAT type question? Then this would be a dumb question. Satyam, if this is numerical answer type question, then this will be a dumb question. In the GATE type of exam, this type of dumb question they will not ask you. In some test series, you can find this question, you can find in some test series as NAT, and then you can waste a lot of time. Is this clear? Then students will waste a lot of time. Students will waste 1 day, 2 day, 3 day. A lot of time students will waste. And then finally, after wasting a lot of time, they will realize that they are correct, others are wrong. Okay, every student will think that I am right, others are wrong. But actually, no one is right. Yes or no? See, if this question is NAT type question, then no one is right. No one is right, no one is wrong. Because this is a poor question. So please don't worry about these things. Okay. Number of NFAs. Yeah, that will be. See, Twinkle is asking what, why. You can also do that. If A is greater than B, that also means A is greater than equal to B. No problem. Okay. So that is also fine. So number of NFAs will definitely be more than this. Okay. Definitely you can create more than, number of NFAs will be actually much more than this. Tell me how many NFAs will be there. Just tell me. For example, your Q is A XYZ. This is your Q and your sigma size is 2. So tell me how many NFAs will be there. What is the number of NFAs? This X is initial state. This is the initial state. So how many NFAs you will get? So you tell me how many NFAs, and how many NFAs without null move? How many NFAs without null move? So what answer you will get? So you can notice here, first you see for transition function, what will happen? 2 power n. Transition function, remember for transition function, that will be 2 power 3 power 6, power 3. Sorry for that. Power 3 multiplied by 3, that is 9. Okay. Yes or no? Is this clear? See, just look at the transition function. So what you will get? This is your 2 power q. This is your 2 power q power 3 multiplied by 3. Okay. So this is your transition functions multiplied by, for final state, how many? That is same. That is 2 power 3. Every state has 2 choices. Every state has 2 choices. How many NFAs without null move? How many NFAs without null move? That will be 2 power 3 multiplied by 2. Okay. And this will be same. That will be 2 power 3. So can you notice? Can you calculate? Number of NFAs will be much more than this. Number of NFA, that will be much more than this number. That will be a very big number. Okay. Much more than this number. So in this question, tell me what answer you will give. You can notice you will give this answer. Okay. Your answer will be option D. So this question we have put in our weekly quiz because this is a UGC NET question. So as it is, I have put it. I did not make any change. See, if I wanted, I could have made this change. Yes or no? Agree with me? If this was my question, if this question is not taken from UGC NET, if I do not take this question from UGC NET, then I will definitely define everything. In the Go Classes weekly quizzes, in the Go Classes test series, every question is well framed. Okay, every question, proper data will be given to you. All the details will be given to you. But I did not make this change. Okay, when I put this question at that time, I did not make this change because this question is from UGC NET and I wanted you to try this question because in the GATE exam also, maybe out of 65, maybe there can be one question which has some ambiguity. Yes or no? In the GATE exam also, out of 65 question, you can find at least one question you can find, 1 or 2 question you can find which will have some ambiguity. Okay. So that is the reason I did not make this change. So you can easily notice that answer will be option D, because no other option is possible. See, whether you consider DFA or NFA, these options are never possible. In this finite automata, if you consider DFA or you consider NFA, definitely when you consider DFA, answer will be option D. If you consider NFA, then number will be more than this. But this is not in the option. So that is the reason answer will be option D. Okay. So this is your complete analysis of this quiz. Please tell me, did you understand all the things? This is the complete analysis of the entire quiz. Understood? Anyone has any doubt in this? All the questions we have seen, each and every question we have seen, the complete analysis of each question we have done. We have not done formality, like for every question, just I give you one minute explanation. That we have not done. We have done the complete analysis of every question. In every question, what mistake student can do, what are the possible variations, what is the proof, everything. Okay, so that is over. Weekly quiz, complete discussion, that is over. So please tell me if you have any doubt. Let me know. Anyone has any doubt? Yes, Harusi, what is your doubt? You can raise your hand. Shivam is asking how we got recurrence relation for length of strings. Hello, Harusi.
हेलो सर, आई एम ऑडिबल?
Yes.
सर एक्चुअली सर बेसिक्स में डाउट है. सर आपने जो स्टार्टिंग का क्वेश्चन लिया था L1 यूनियन L2 स्टार इक्वल टू L1, तो जब हम एम्प्टी स्ट्रिंग लेते हैं तब तो मुझे अंडरस्टूड हो चुका है. जब आपने एक एग्जांपल लिया था L1 इन L1 का सेट L1 यूनियन L2 होल स्टार इक्वल टू L1 स्टार. L1 लैंग्वेज है, L1 कंटेंट A and B. L1 is a set contain A and B, and L2 contain set L2 contain AAB, double AB.
Okay.
Sir, L2 is subset of L1.
No. How is L2 is subset of L1? Is L2
No,
subset of L1?
So it is not a subset of L1. I
You
want
tell
to
me.
complete the question. Yeah. So here you told that L1 union L2 star generating all the string which L1 is generating. तो मुझे ये डाउट है खाली इसमें, समझा आपका सॉल्यूशन. L1 यूनियन L2 में हमारा और एक स्ट्रिंग बढ़ जाएगा AAB, तो इनडायरेक्टली L1 यूनियन L2 ज्यादा स्ट्रिंग जनरेट करेगा L1 से, क्योंकि एक स्ट्रिंग ज्यादा है AAB में. तो आप इक्वल कैसे कर रहे हैं सर? मैंने मैन्युअली कैलकुलेट किया, मैन्युअली सेम आ रहा है सर, तो भी लॉजिक नहीं क्लियर हो रहा है.
ओके, लेट मी गिव यू वन एनालॉजी. ओके, एक एनालॉजी देता हूं मैं. वो है कि कुछ ऐसी सी है, मान लो आपके ऊपर, ओके, ये आप हो, आपके ऊपर अगर मैं 10,000 किलो का वजन रख दूं, तो उसके बाद में अगर मैं 1 किलो और इंक्रीज कर दूं तो कुछ फर्क पड़ेगा? मतलब मैंने ऑलरेडी 10,000 किलो का वजन रख दिया मैंने आपके ऊपर, उसके बाद अगर मैं 1 किलो और इंक्रीज कर दूं, कुछ फर्क पड़ेगा? फर्क नहीं पड़ेगा. यू आर ऑलरेडी गॉन, राइट?
ओके सर,
ओके, समझ रहे हो? यू आर ऑलरेडी गॉन. उसके बाद मैं 1 किलो 2 किलो एक्स्ट्रा वजन रख दूं, कोई फर्क नहीं पड़ेगा, राइट? सी द सेम थिंग इज हैपनिंग इफ यू नोटिस दिस A, B. Okay, whatever extra you have, I don't care. Whatever extra you have, I don't care. Now, this A, B are very powerful. Okay, so they will create everything. See, they will create everything. The point is, whatever extra you have, you can have. For example, you can have, for example, maybe A, maybe AB. Okay, these extra things you can have. Now, the point is, in L star, you will get every string. You will get every string. You will get every string. Okay, every string, because this A, B are so powerful, they can create every string. You take any string. For example, you take any string A, B, B, A, B, A, B. Okay, you take any string. Now you can notice this string also, this A, B can create. This is A, this is B, this is A, this is A, this is B, this. So you can notice, so these two are very powerful, they can create any string. So the point is simple, that if I give you this language A, B, now whatever I have does not matter. Now whatever I have does not matter. Your L star will be set of all strings. This is already set of all strings. See, this is already set of all strings. Now, because this is already set of all strings, so what extra you can create? Are you getting my point? you already got all the strings, so what extra you can create? See what I'm saying, please understand. I am saying that let's assume you only have a comma b. Let's assume you only have a comma b.
Yes,
Now
sir.
also you can notice that your L star is sigma star.
Yes.
You already got all the strings, all the strings you already got. So now these people, they cannot create something extra. These people, they cannot create anything extra. You
ओके
already have
ओके
all the
बिकॉज
strings.
ओके अगर सेट में ए कॉमा बी है तो उससे हम और हर एक स्ट्रिंग जनरेट कर सकते हैं, इसलिए वो इट कंटेन ऑल द स्ट्रिंग्स, वी कैन से
You
दैट.
see, there is nothing more than sigma star. Sigma star has all the strings. कैपिटल में लिखा है मैंने, कैपिटल
यस
में
यस
अंडरलाइन करके लिखा है all the strings. सिग्मा स्टार के अंदर सब कुछ है, सब कुछ है. तो अगर कोई नया स्ट्रिंग अगर आएगा तो वो ऑलरेडी सिग्मा स्टार में है. मतलब
ओके
समझ रहे हो? इट्स लाइक
यस.
इसका एक और एग्जांपल कि आज ओके इस वक्त मान लो कि एलन मस्क है. एलन मस्क को अगर आप 100 रुपए और दे दोगे, क्या फर्क पड़ जाएगा?
ओके
ओके,
गॉट इट सर.
समथिंग लाइक दैट. एलन मस्क को 100 रुपए और दे दो, क्या फर्क पड़ेगा? ठीक है, तो समथिंग लाइक दैट. सिग्मा स्टार ऑलरेडी हैज एवरीथिंग. दिस सिग्मा स्टार, it has all the strings, it has all the strings, so nothing extra you can create. Whatever you create, that is already there, that is already here.
ओके ओके सो सर और एक डाउट है, तो
One
इसके
more thing,
रिलेटेड ये डाउट.
see one more thing. Let's assume this is your language a comma b, and let's assume this is your language a comma b double a a b. Consider these two languages. Okay, there is L1, there is L2. Now you can notice that here you using these two strings, you can create this string double a, then you can create double a, then you can create ab, then you can create double a, right? So I can say that I can say this string belongs to L2 whole star, because from this L2, using these two, you can create this string, you can create. Okay, create.
Yeah.
Yes or no?
Yes.
But the point is, this string you can create using these also. Okay,
Yes, sir.
वो एक मीम है ना कि हम भी कर लेंगे, हम भी कर लेंगे. तो so this a comma b, they can also a b, so like this. Okay, so whatever these two people are bringing, see these two people are doing like this, double a a b a. So whatever these two people will bring, whatever string these two people will bring, that is that these people also can bring. So these two people cannot bring anything new. Whatever you create with these two, whatever you create, that you can also create using a comma b.
Got it,
Okay,
sir.
हम भी बना लेंगे, something like that. So like this. Any other doubt?
Yes, sir. Language contain a raised to 2n and greater than equal to 0.
Okay,
A raised to
and
2n and और m contained a raised to 2 and comma epsilon. सर एक्चुअली सर वो उसमें ही प्रॉपर बेसिक्स में थोड़ा सा गड़बड़ हो रहा है. l डॉट m इक्वल टू l कैसे आ रहा है सर?
l डॉट m इक्वल टू क्या आ रहा है?
l.
l डॉट इक्वल टू l आ रहा है.
यस सर, बेसिकली इट इज
तो
क्वेश्चन ऑफ
वो
लेक्चर
इसकी वजह
3T.
से आ रहा है ना, वो इसकी वजह से आ रहा है.
सर
एक
मतलब
बार
समझा
चेक
नहीं
करो.
मुझे आप.
अरे ठीक है, एक बार बस lm फाइंड करो. चलो lm, चलो फाइंड करते हैं. Okay, your
Sir,
l is what? Your l is what? That is epsilon a square, a power 3, a power 4. Tuck, tuck, tuck. Okay,
yes,
what is your
okay.
m? That is a square epsilon. Now see,
Okay.
see. Now this person, because of this person, all these people will come. See what will
Right.
happen. Because this epsilon will, okay, see this epsilon, that will give you epsilon. This a epsilon, that will give you a. This a square epsilon, that will give you
Okay.
a square. That a cube epsilon, that will give you a cube. A power 4 epsilon, that will give you a power 4. Already you got L. See, using this a square, you whatever you get, that is already here. And now are you getting? With this, a square is already here. With this, a cube is already here.
Okay. Got
With
it,
this, a power 4 is already here. So you are getting, basically, ultimately, you are getting L.
Okay.
Any other doubt?
सर ऐसा ही और एक है, एक लास्ट ही है, सेम ही है. सर
Tell me.
L contains sigma star.
L contains sigma star.
Yes.
L contains
L
sigma star.
No. L is equal to sigma star. And
Yes.
sir, m equal to m contain 0, 1 and epsilon. सर इधर भी एल एम इक्वल टू सिग्मा स्टार एप्सिलॉन की वजह से आ रहा है क्या?
यस 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 यस, अगर ये एप्सिलॉन नहीं होता तो एलएम क्या होता? सो फ्रॉम हियर यू गॉट एलएम इक्वल टू सिग्मा स्टार, क्योंकि इस एप्सिलॉन की वजह से ये सारी स्ट्रिंग्स एलएम में आ जाएंगी। ठीक है, जब आप एलएम करोगे उस एलएम के अंदर एल की सारी स्ट्रिंग्स, ये एल है, इसकी सारी स्ट्रिंग्स जो हैं वो एलएम में आ जाएंगी, क्योंकि कोई भी स्ट्रिंग इसके साथ मैच करके हर स्ट्रिंग इसके साथ मिलके एलएम में आ जाएगी। तो एलएम
और
इज
सर
इक्वल टू
जीरो,
सिग्मा स्टार।
और
अब
सर
अगर
जीरो
मैं
वन
मान लो
ऑलरेडी
चेंज
है।
कर दूं, मैं इस एप्सिलॉन को हटा दूं, अब एलएम क्या होगा? अब एलएम क्या होगा?
सर
नाउ यू कैन
तो भी
चेक दैट विल बी सिग्मा प्लस। अब एम्प्टी स्ट्रिंग नहीं आएगी, बाकी सब आ जाएगा। ओके, बिकॉज नाउ यू हैव ए कॉमा बी, सॉरी 0,1। सो नाउ अब क्या होगा कि कोई भी स्ट्रिंग जो यहाँ पे सिग्मा स्टार में तो सब कुछ है, एल तो सिग्मा स्टार है और सिग्मा स्टार में सब कुछ है, उसके आगे बस 0 और 1 लगना है, तो हर
ओके
स्ट्रिंग बन जाएगी आपकी। ओके, आपके 0 भी आ जाएगा, क्यों? एप्सिलॉन के साथ 0 मिलके 0 बन जाएगा। ओके, एप्सिलॉन के साथ 1 बन के 1 बन जाएगा। आपको 0 0 0 भी मिल जाएगा, क्योंकि 0 के साथ 0 मिलके 0 0 बन जाएगा। ओके, सो आपको सब मिलेगा, बस एम्प्टी स्ट्रिंग नहीं मिलेगी।
ओके सर, गॉट इट सर प्रॉपर्ली।
ओके,
और सर लास्ट डाउट है सर, कौन सा भी एक डीएफए दिया रहता है और सर उसका लैंग्वेज फाइंड आउट करना है, तो सर वो बहुत ज्यादा टाइम लगता है, तो उसका कुछ स्पेसिफिक कुछ वे ऑफ थिंकिंग है क्या?
जो
whenever
भी
a
वे ऑफ
DFA
थिंक
has been given।
जो भी वे ऑफ थिंकिंग था वो सब हमने लेक्चर्स के अंदर देख लिया, उसके अलावा कोई वे ऑफ थिंकिंग नहीं है। इन चीजों की कोई एल्गोरिथम नहीं होती कि मतलब ऐसी कोई एल्गोरिथम नहीं है जो आपको ऐसे कोई जिसको आप जिस उस एल्गोरिथम के पास आप डीएफए डालो और वो आपको लैंग्वेज निकाल के दे दे। ऐसा कुछ नहीं है, कोई ऐसा कोई सिस्टमेटिक प्रोसीजर नहीं है, सिंपल एनालिसिस है। जितने भी हमने डीएफए क्रिएट किए हैं, जितने भी डीएफए क्रिएट किए हैं, बिल्कुल एकदम एक लॉजिकल थिंकिंग से हमने क्रिएट किए हैं।
यस
ठीक है,
यस
अगर आपने देखा हो हर एक
यस
लैंग्वेज
सर।
जो है, हर एक लैंग्वेज उसका हमने डीएफए लॉजिकल थिंकिंग से क्रिएट किया है। हमने ऐसे नहीं किया कि लैंग्वेज को पहले एनएफए बनाया क्योंकि वो इजी है, फिर एनएफए को डीएफए में क्रिएट कन्वर्ट किया, फिर मिनिमाइज किया, हमने ऐसे नहीं किया। लॉजिकल थिंकिंग से सारे डीएफए क्रिएट किए हैं। तो अगर आप वैसे अगर और भी जैसे सारे डीएफए अगर आप खुद से क्रिएट करोगे तो ऑटोमेटिकली आइडिया लग जाता है, बात ये है। ओके, बात ये ऑटोमेटिकली आइडिया लग जाता है, लेकिन फिर भी कुछ ऐसे डीएफए होंगे जिनकी लैंग्वेज आप सच में मतलब फाइंड आउट करना बहुत मुश्किल है, बहुत कॉम्प्लिकेटेड लैंग्वेज होती है। जैसे एक क्वेश्चन हमने देखा था, एक इसरो का क्वेश्चन देखा था ना, जिसमें 8 लेंथ स्ट्रिंग पूछा
यस
था,
सर।
है ना?
यस
उस डीएफए उस वो जो डीएफए है, उस डीएफए की जो लैंग्वेज अगर आप फाइंड आउट करने की कोशिश करोगे, बहुत ही कॉम्प्लिकेटेड लैंग्वेज बनेगी। ऐसे नहीं है कि सिंपल सी
राइट
लैंग्वेज बन जाएगी कि कंटेन ए बी, स्टार्ट्स विद ए बी। सिंपल लैंग्वेज नहीं है, उसकी काफी कॉम्प्लिकेटेड लैंग्वेज है। वो लैंग्वेज मैंने कमेंट में लिखी है, उस इसरो क्वेश्चन की कमेंट्स में जाना, मेरी कमेंट आपको मिलेगी, उसके अंदर मैंने लैंग्वेज लिखी हुई है। 2 लाइन की लैंग्वेज मैंने लिखी हुई है, उस लैंग्वेज को आप पढ़ोगे तो आप बोलोगे कि ये क्या है, मतलब ऐसी लैंग्वेज, ऐसी कॉम्प्लिकेटेड लैंग्वेज। तो बात यह है कि अगर कोई कोई डीएफए है जो एकदम ही नया डीएफए है, कॉम्प्लिकेटेड सा डीएफए है, फिर वो सबके लिए कॉम्प्लिकेटेड है, वो फिर आपके लिए नहीं, वो फिर सबके लिए, आपके लिए, मेरे लिए, सबके लिए। ठीक है, लेकिन
ओके
अगर कोई स्टैंडर्ड डीएफए है जो हमने ऑलरेडी क्लास के अंदर क्रिएट कर रखा है, तो वो तो फिर मतलब बहुत ईजी है। और मोस्ट ऑफ द
यस
टाइम गेट के अंदर मोस्ट ऑफ द टाइम स्टैंडर्ड चीजें आती हैं। स्टैंडर्ड जो चीजें है
ओके
ना, जो स्टैंडर्ड डीएफए, स्टैंडर्ड एनएफए, मोस्ट ऑफ द टाइम वही आता रहता है, मोस्ट ऑफ द टाइम।
ओके
और अगर कोई
ओके सर।
स्टैंडर्ड चीज नहीं आ रही है गेट के अंदर, अगर कोई स्टैंडर्ड डीएफए नहीं है, कोई नया डीएफए, थोड़ा कॉम्प्लिकेटेड सा डीएफए है, तो ऑप्शंस को एलिमिनेट कर सकते हो। या तो ऑप्शंस को एलिमिनेट कर लो, या फिर वो आपसे लैंग्वेज पूछेगा ही नहीं, वो आपसे ये पूछेगा कि कौन सी स्ट्रिंग एक्सेप्ट हो रही है, कौन सी स्ट्रिंग एक्सेप्ट नहीं हो रही है, या फिर वो आपसे कुछ और पूछेगा। ठीक है, तो जो क्वेश्चन मेकर होता है, देखो अब अगर मैं अगर क्वेश्चन मेकर हूं, तो जब भी मैं क्वेश्चन क्रिएट करूंगा तो मैं क्वेश्चन ऐसा क्रिएट करूंगा जो स्टूडेंट से सोल्व हो जाए। ये क्वेश्चन
राइट
मेकर की मेंटेलिटी होती है। जब भी हम क्वेश्चन क्रिएट करते हैं तो दिमाग में रहता है कि ऐसा भी नहीं बनाना है कि मतलब यार क्वेश्चन स्टूडेंट से सोल्व ही ना हो, कि किसी भी स्टूडेंट से क्वेश्चन सोल्व ही नहीं हो रहा, फिर उस क्वेश्चन का कोई मतलब नहीं है। क्वेश्चन ऐसा होना चाहिए कि जिसने अच्छी प्रिपरेशन कर रखी है उससे सोल्व हो, और जिसने अच्छी प्रिपरेशन नहीं कर रखी, जो रट के गया है, उससे पक्का गलती हो। क्वेश्चन ऐसा होना चाहिए, द बेस्ट क्वेश्चन इज दैट।
ओके
ओके, तो
यस
जो
यस
क्वेश्चन मेकर की जो मेंटेलिटी होती है वो भी ऐसी होती है। वो आपको मान लो एक कॉम्प्लिकेटेड सा डीएफए दे दिया, 8 या मान लो कि 6 या 8 स्टेट का डीएफए आपके सामने है। ठीक है, कॉम्प्लिकेटेड सा डीएफए, बहुत सारे ट्रांजिशंस हैं, स्टैंडर्ड डीएफए नहीं है, तो उस सिचुएशन के अंदर वो आपसे लैंग्वेज पूछेगा ही नहीं। समझ रहे हो? वो आपसे बदला थोड़ी लेना चाहता है
Yes,
कि
sir.
1 लाख गेट एस्पिरेंट से बदला लूंगा मैं, एक से भी सोल्व नहीं होगा, उसको कोई ऑस्कर प्राइज थोड़ी मिलने वाला, उसको कुछ मिलने थोड़ी वाला है कि हाँ भाई प्रोफेसर तुम्हारे क्वेश्चन को एक भी बंदा सोल्व नहीं कर पाया। ठीक है, अगर
सर
ऐसा हो जाएगा
एग्जाम्पल भारी
वो
दिया आपने.
प्रोफेसर डम्ब है, अगर ऐसा हो जाएगा वो प्रोफेसर डम्ब है, उसको क्वेश्चन क्रिएट करना नहीं आता।
ओके सर.
ठीक है, तो बात इतनी सी है, कोई भी क्वेश्चन जब क्वेश्चन मेकर क्रिएट करता है तो सबसे बेस्ट क्वालिटी, सबसे बेस्ट क्वेश्चन वो होता है, चाहे इजी हो सकता है हार्ड हो सकता है, लेकिन सबसे
राइट.
बेस्ट क्वेश्चन वो होता है जिसको अच्छी प्रिपरेशन वाले लोग सोल्व कर पाए, जिनका एनालिसिस अच्छा है वो लोग सोल्व कर पाए, और जो रट के गए हैं वो लोग उसको गलती करें, वो सबसे बेस्ट क्वेश्चन होता है। ओके, सो डोंट वरी, मतलब ऐसा नहीं है। अब आप कई कई बार स्टूडेंट्स पूछते हैं कि सर अगर इसमें ऐसा होता तो क्या होता, मतलब समझ रहे हो कि अगर क्वेश्चन अगर ये ऐसे होता तो
Yes.
कैसे होता। तो अगर क्वेश्चन ही अगर डम्ब है, अगर क्वेश्चन वेल फ्रेम्ड नहीं है, तो फिर ये वोट इफ क्यों लगा रहे हो? वोट इफ स्टूडेंट्स को बहुत शौक होता है कि सर वोट इफ, ठीक है, तो वोट इफ करके तो फिर मैं आपसे कुछ भी पूछ लूंगा, मैं आपसे बोल दूंगा कि वोट इफ दिस क्वेश्चन कम्स इन द गेट एग्जाम, 2 + 2 = 2 एंड ऑप्शंस आर लाइक दिस, अल्फा, पाकिस्तान, थर्ड ऑप्शन इज थर्ड ऑप्शन इज लाइक दिस। सो अगर इस तरह का कोई डम क्वेश्चन है, ऐसा डम क्वेश्चन देखने के बाद भी कुछ स्टूडेंट्स बोलेंगे सर व्हाट इफ दिस क्वेश्चन कम्स इन द गेट एग्जाम। ओके, इवन मतलब साफ साफ दिख रहा है कि क्वेश्चन डम है, क्वेश्चन का डेटा क्लियर नहीं है, क्वेश्चन वेल
Right.
फ्रेम नहीं है, क्वेश्चन के अंदर डेटा मिसिंग है, क्वेश्चन एम्बिगुअस है। ठीक है, मतलब सारी जितनी भी दिक्कतें हैं वो हम आपको बता देंगे, मैं आपको सारी दिक्कतें बता दूंगा कि ये ऑथर डिपेंडेंट है, ये एम्बिगुअस है, ये इल फ्रेम्ड है, इसके अंदर ये होना चाहिए, इसके अंदर ये डेटा नहीं दिया हुआ, मैं आपको सारी चीजें बता दूंगा। लेकिन ये सारी चीजें बताने के बाद में कुछ स्टूडेंट्स का मैसेज आएगा सर व्हाट इफ दिस क्वेश्चन कम्स इन द गेट एग्जाम, कौन सा ऑप्शन लगाना चाहिए? तो बात वही है, समझ रहे हो मेरी बात? तो
Yes,
so
sir.
don't worry about these things. Okay,
Yes, sir.
any
Sir,
other
thank
doubt?
you once again. No, sir.
Any other doubt? Any other doubt? Shivam is asking how we got the recurrence relation. See, Shivam, this was your language. Your language was this, that you have empty string and then you can create two more string. You can create, you can add a at the end, or you can add ba at the end. Similarly, from here also you can create two more string. You can add a at the end, or you can add ba at the end. From here also you can create two strings. You can add a at the end, you can create a at the end, or you can add b at the end. Like this, like this you can keep creating, like this you can keep creating. Okay Shivam, so now you can notice that. Tell me one thing, अगर मान लो कि मुझे 5 लेंथ की स्ट्रिंग क्रिएट करनी है, मुझे आई वॉन्ट टू क्रिएट 5 लेंथ स्ट्रिंग। ओके, 5 लेंथ स्ट्रिंग अगर मुझे क्रिएट करनी है तो मैं क्या क्या कर सकता हूं? इफ आई वॉन्ट टू क्रिएट 5 लेंथ स्ट्रिंग देन व्हाट आई कैन डू, देखो मैं क्या कर सकता हूं, मुझे क्रिएट तो 5 लेंथ की करनी है, लेकिन मैं क्या कर सकता हूं, व्हाट आई कैन डू, आई कैन टेक अ 4 लेंथ स्ट्रिंग, आई कैन टेक अ 4 लेंथ स्ट्रिंग, मींस आई टेक अ 4 लेंथ स्ट्रिंग, and in that, from that 4 length string, tell me one thing that I need to do. You already have 4 length string, you already have 4 length string, what I can do to create a 5 length string? My purpose is 5 length string, this is my purpose is 5 length string, this is my purpose. So what I can do, I can take a 4 length string and at the end I can put a. Yes or no? I can take 4 length string and at the end I can put a. Or what I can do, I can take a 3 length string and then at the end what I can do, at the end I can put ba. Yes or no? So notice one thing, that if I want to count n length strings, this is the number of n length strings, this is the number of n length strings. Okay, how many n length strings I can create, this is the number of n length strings. So what I can do, see, this will be equal to, you can, let's assume these are the 4 length strings, let's assume these are the 4 length strings, these are all the 4 length strings. Are you getting my point? Let's assume these are all the 4 length strings, these are all the 4 length strings. So tell me how many you have here, how many we have here? Sorry, these are n minus 1 length strings, these are n minus 1 length strings. So tell me how many are here? Fn means n length strings, number of n length strings, number of n length strings. So tell me how many n minus 1 length strings are here? That is fn minus 1. Fn minus 1 means number of n minus 1 length strings. In these strings, all I need to do just add a at the end. Okay, in these strings, I just add a at the end. So I will get n length strings. The same I will get, yes or no? Agree with me? Because what I'm doing, I'm just adding a at the end. I'm just adding a at the end. I'm just adding a at the end. So tell me how many I will get finally? How many I will get finally? I will get the same. Here you have fn minus 1. Here also I will get fn minus 1 because I am just adding symbol a at the end. Okay, this is your string. I am adding a at the end. This is your string. I am adding a at the end. So the same number of strings you will get. Similarly here, this is your fn minus 2. These are the n minus 2 length strings. What I will do, I will just add b at the end. So I will get this. So finally, how many n length strings I can create? That will be this plus this. These are the n length strings. Shivam, did you watch recurrence relation playlist in the discrete mathematics? Shivam, did you watch recurrence relation playlist in the discrete mathematics? You did not watch. That is the reason you are having this doubt. Okay. So what you do, this is very easy. You skip it for now. For now, you skip. Okay. This is so easy that once you watch that playlist in the discrete mathematics, recurrence relation, once you watch it, you will immediately get this. Okay. Is this clear, Shivam? See, in the recurrence relation in discrete mathematics, in the combinatorics, we have seen recurrence relation. So once you study recurrence relation, then this question is very easy. You won't even, I can say, you will think that this is very trivial question. But first you have to watch that. So don't worry about it. For now, you can skip it. This question you skip for now. Okay, Shivam? Any other doubt? Shivam is saying, I have done half of the combinatorics. Very good. At the end of the combinatorics, we have recurrence relation. So once you complete the combinatorics, then this question is already done. Okay. So what you do, you can write in your notes. You can write some reminder. You can write that when you complete the combinatorics, once you study the recurrence relation, once you complete that playlist, then what you do, then you solve this question. Okay, Shivam? Any other doubt? Anyone? Hello, Kavya?
Yes. Hello.
Yes.
Hello. Am I
Hello.
audible, sir?
Yes.
Sir, sorry, sir. I don't have a subject doubt, but I have a little general doubt. It is my first live session.
Yeah, tell me.
So, sir, actually, I joined last month. So, sir, from there, like I live in my college. I'm in IIIT Dharwad currently. So I went to my home for 10-15 days. So my consistency like break a little bit. So sir, अभी actually क्या है discrete mathematics में I have not completed. मतलब मेरा पहले से मैंने पढ़ रखा है, but आपका जो आपने पढ़ा है उससे मैंने भी पूरा complete नहीं किया है. Combinatorics भी.
Kavya, can you call me just for example in 5 minutes? You can call me on this number.
Okay, sir.
Okay, because
Okay,
this is not a technical doubt, so we can discuss over call also.
Yes, sir.
Okay?
Sure, sir.
This is my WhatsApp number. You can call me here. Okay. So in 5 minutes you can call me. If any student ever wants to talk to me, you can send me a message on this. This is my WhatsApp number. Okay. So first you can send me a WhatsApp message. We can schedule a call and then we can talk. Okay. So this is for all the students. You can send me a WhatsApp message. We can schedule a call and then we can talk. So Kavya, you can call me on this number. Okay. Because your doubt is non-technical. We can discuss this over call. Okay.
Yes. Okay,
You can
sir.
call
Thank
me
you
in
so
5
much.
minutes. Okay. Thank you.
Thank you so much.